according to that. So based on the rock mass structure, on the tunnel overburden, and the intact rock strength, we can understand whether we are thinking of a structurally controlled failure or a stress-induced problem. So this is very, very important for us. Before getting these numbers into formulas, first assess the potential. Then we can go, for example, and use iron weights of rock science if we have assessed the weights, or to go to a shear developed problems around our periphery and assess the, let's say, the principle, the dictating parameters. So in this example, we assess the ground types, their properties in the GSI classification. So we assess that we have three kinds of rocks, for example, in siltstone. So you see S because it's a siltstone. We have assessed the intact rock properties and all the hydrogeological conditions along the tunnel. So we have defined all the rock mass types. But before using all these numbers below the table, we can go and say, okay, our TBM will give, in this kind of overburden, 70 to 100, 100 to 150, or more than 150 in this tunnel, these different kind of problems. So then every kind of combination of these rock mass types, you can have discontinuity control over breaks, crown failures, shallow shear failures, or squeezing ground. So your engineering geological appreciation is not only limited to a number, but also to a table that it is qualitative here, but then can become qualitative in the next steps, and see what kind of rocks can give you this kind of squeezing. So now I'll go to some last slides. So when you have squeezing, you have two scenarios. You either go to a very rigid support cell or you're going to a flexible support cell. So in this case, for example, when we had clays, hard clays in 120 or 2020, you see they started to do this very, very rigid support cell, but they had problems, and you see over that magenta line, all this is above the limits. So we have an invert fracture, and then we have a collapse of the tunnel. And then they tried the yielding support system with many sliding joints and self-drilling yielding anchors. Again, they have problems with that because all these support cell did not converge, and unfortunately it was very, very difficult to place in these yielding anchors. So they did something in between. So they tried to make a rigid support cell, and then behind that support cell, closing very, very fast. This is 1 meter gunite, closing the invert. So you see how very close to the temporary invert we have a closure of the B phase. Engineering geology is fundamental for the TBM selection methodology. I don't have the time to analyze that, but for the three first steps, engineering geology is fundamental. For the engineering geotechnical model, for the TBM sister behavior analysis, and the preliminary TBM selection. Then we have to manage all the material. So all these assessments from the step 1 for a tunnel section, the step 2, the TBM behavior analysis, and then the preliminary TBM selection is based in an engineering geological analysis. And finally, engineering geology is ahead many times of monitoring of tunnels. So responsible not only to take the measurements, but to analyze them, to put them in a database so we can have big data and work in AI definition. So you can see in an urban tunneling how many measurements we can have. So this is $1 million of budget behind that. And engineering geology is responsible for carrying that and taking decisions many times. So the risk, reducing the risk and this uncertainty can be done through the GBR, the Geotechnical Baseline Report. So here we need to define the line, where is your responsibility as an owner and where is my as a contractor, and vice versa. So the risk allocation, a condition equal or less adverse than the baseline, can go to the contractor or the conditions significantly more adverse can go to the owner. But here, please note that the definition of the baseline report has a prerequisite that we have identified all these geohazards prior to all this analysis. So my concluding remarks, you can read it. I just want to highlight that the anticipated behavior analysis is valuable before using any kind of a number. Engineering geology in tunneling is more than a number. It is an integrated, interpretive discipline central to safe, efficient, and adaptive tunneling practices. So we face a lot of challenges in the next years, and we face many good moments when a breakthrough comes. Everybody is happy. Engineering geology is responsible for this succession, successful to remediate, to manage all the risks and provide solutions of the temporary support philosophy and the reevaluation of the design of the construction. Thank you very much for your attention.
So thank you very much, Professor Vassilos. It is now actually finished, the advancement of tunneling methods and the importance of engineering geology, well presented, and also very excellent presentation. Please give a big clap to Professor Vassilos for his nice presentation. And we are still more than 1 hour behind our schedule. So in that case, I'd like to again request our all presenters, because previously the allocated time for all the keynote speakers, it was more than around 30 minutes. But unfortunately, because of the morning session delay, it is very difficult to maintain the time, also your lunch time. In that circumstances, I'd like to request all the honorable keynote speakers, please be strict, and if necessary, please try to skip some of the slides to manage the time. Otherwise, you will not get the lunch the way it is mentioned. So please give me support in case of presenting your presentation. Our next presenter is the Dinesh Kumar Napit from, I think he will present, and he will present his talk on the role of Department of Mines and Geology in advancing engineering geological sciences. I think you are here. Yeah.
Thank you.
Thank you.
Respected chairperson and the co-chairperson of this session, and the distinguished guest, and all the participants, good afternoon and namaste. I'm Dinesh Kumar Napit, Director General of Department of Mines and Geology. Actually, we are already out of our time. I'll try to be within my time limit, or I try to be before that. I will finish my presentation.
Yeah, thank you.
Actually, Department of Mines and Geology, by profession also I am a geologist, and Department of Mines and Geology is also working in the field of engineering geology. Department of Mines and Geology is the only government organization which is mainly responsible for all kinds of geological exploration, geoscience survey, mineral exploration, and also this mines and mineral licensing and regulations also. So this is the outline of my presentation. I will start with the introduction of Department of Mines and Geology, and I will concentrate my presentation within the activity of DMG related to this engineering geological studies in Nepal. So in the morning, we all are talking about the importance of engineering geology all over the world. And Nepal, we all know that Nepal is in active seismic zone, having a very rugged topography, fragile geological condition, and we have been experiencing of a lot of earthquakes, landslide, and you see when we construct a road in a mountainous area, you see what will be the condition in the first phase, you know. So because of the rapid infrastructure development, intense rainfall induced landslide, similarly like climate induced impacts like a gulf and other things, this flooding, all these things made Nepal very vulnerable to the disaster and a lot of these geological hazards. So engineering geology is always an important topic for all of us, and Department of Mines and Geology is also having its activity concentrating on geological studies, engineering geological studies in various parts of the country. So Department of Mines and Geology is the only one government organization, I already told you, mainly responsible for all kind of geological survey, mineral exploration, and actually Office of Irrigation and Geology was long established back in 1926, and now Department of Mines and Geology was established in 1997, and our office is located in Lanchor, just nearby from here. So one of the activities DMG is now carrying on is in the landslide hazard assessment and mitigation. We are doing large-scale landslide mapping and also landslide inventory mapping. And we are also giving our technical assistance or technical input to other organizations like Ministry of Home Affairs, NDRRMA. Upon their request, we also carry out some of the study of the landslide, and we also supporting the local government as well. So these are the activities, some of the example of activities DMG has already carried out, the detailed investigation of landslide in several districts, several locations. For example, in Acham, in Kaski district, this is a Jure landslide in the Sindhu-Palchok district that has dammed the Sunkosi river before. And we are also done some of the work in MLMC, the flooding event. Also, after Workha earthquake in 2015, we have carried out with the coordination of Home Ministry and other institution from the government side, and also with the university. There are risk areas in several districts lying along these seismically active areas. There were 107 settlements have been studied in a district, so that we can refer them for the safe settlement. And we have done also a very detailed, it was a rapid assessment and also detailed assessment of the landslide in 19 districts. This is the landslide hazard zonation mapping we are doing, and we have been carrying on continuously, but this is, we have not completed all over our country. This is the example of awareness program we are carrying out in the local government, local communities, local government officials, emergency responders, engineers and geologists, as well as environmentalists and students. Now we have also started working on early warning system of landslide early warning system. The one project is undergoing with the support of German government. It will be concluded in the last of this December, and we are trying to have this early warning system established in our department. So some of the damage assessment we have done recently after the heavy monsoon rainfall in various parts of the country, mainly in the central Nepal. These are some of the example after the heavy monsoon rainfall in Melamchi area. This our water resource project was also very badly damaged, and this is the scenario of the Melamchi area after the incident. In 2024 also, there was a heavy rainfall in the Kathmandu Valley also, and there was a number of landslide, and there was a very various debris flow, flooding, and some area destroying the local infrastructure, local people's houses. People are also died in that incidents also. This is the drone mapping we have completed, and based on that drone mapping, we have been assessing the hazard and causes also as well. So this is the drone mapping of Lalitpur area. We call it Nallu area, Nallu corridor. So you can see the extent of the damage of that area. Similarly, this is the study of the Kafal Dada quarry area. Actually, we have not done this kind of work before because, you know, the Department of Mines and Geology also giving licenses to several mining companies for construction mining, material mining. And this is the one of the construction material mining in the Kafal Dada area. And after heavy rainfall, in that area also, there was a very large-scale damage in the mines area. Also, you can compare the extent of the damage. The picture you can see before and after the so the same monsoon area season, this kind of damage has happened in Lalitpur area. There was debris flow and soil slide and debris accumulation and damage of structure in various parts, including this hospital area also. You see, during the monsoon season, because of the heavy rainfall, there was a flooding in the Rosi area. It is in the Kavri district, in the eastern part of Kathmandu. There was a very bad damage of this local community, local road. Still, there is a highway which is very badly affected. We have not recovered from that, and department road is now going to be reconstructed again. And one of the very highlighted and very, actually very big event happened during the monsoon season. 35 people will buried within one area with 4 vehicles buried in debris. It is Jhaple Khole area. It is in the Priti highway area, highway. So during the night time, the landslide occurred. We could not rescue them. 4 vehicles were buried at the same area. So this is the extent of landslide happening even after the construction of the road. So it shows that what is the importance of engineering, geological research and studies in our country, because there are a lot of infrastructure is growing every year. And even after the construction of the road, how it is important to monitor landslide regularly. Apart from that, Department of Mines Geology is also doing mainly concentrating also on mineral exploration. This is the example that several commodities have been identified in and distributed in various parts of the country. Actually, we have identified 63 commodities, and from the occurrences to the mineral deposit. And based on that mineral deposit, and we are doing a detailed exploration and for the deposit evaluation with topographic survey, sampling, and even core drilling and prospect mapping. We will evaluate the deposit and prove the deposit. So this is the recent findings we have discovered. This is the Kompukat magnesite deposit. We have completed all of this kind of work, and we have approved the deposit, and it is of economic kind. And similarly, another iron deposit in the western part of Nepal. We have already completed this kind of exploration work. So based on that, Nepal has been doing mining works, mainly from the private sector. There are some international investor also, companies are also working. But Nepal's mines is mainly based on the limestone mining, and we have a cement industry. We are self-sufficient in the cement supply in Nepal. So these are in the list you can see, these are the minerals we are mining right now, and we have provided about 144 mining licenses to private sector as well. So this is the basic thing. The Department of Mines and Geology actually doing the geological mapping. Every geologist will start doing geological mapping for any purposes. So we have now in a second generation of the mapping phase. First generation was mapped within the scale of 1 is to 2050, 250,000 scale. Now we are publishing and we are covering whole Nepal with the scale of 1 is to 50,000 scale, almost covering middle part of the area. You know, in the southern part also, we have completed the mapping, but in the northern part is a high Himalaya. We have not completed that part in detail. So we could not publish that map in 1 is to 50,000 scale. But we have compiled all these maps in a whole Nepal, the geological map of Nepal. So these are the application of a geological map we have produced. Other institution for hazard assessment, for mineral exploration, for any infrastructure assessment and design, they can use these maps. And we are also providing this information to any stakeholder, any people or any companies for any project. The geological map and geological information and other information we are providing. Focusing on the urban areas and rapidly growing cities, we are also doing engineering and environmental studies. So actually we have started this program with the German government's collaboration in 2001, I think. And we have completed this kind of studies in Kathmandu Valley, Pokhara, major part of the cities we have completed this. So actually we do this SPT survey, power auger survey, and we have a geotechnical lab and we analyze all these things, samples, and then we will we generate this map. Now we are trying to adapt the new technology and advanced tools also. We have a GIS and remote sensing lab we are using for this landslide mapping and landslide hazard mapping also. We are doing this geophysical survey also, electrical resistivity survey, ground penetrating radar, seismic studies, proton magnetometer survey. And actually, recently we also have done some seismic survey for the petroleum exploration also, and we also completed one drill hole of 4,013 meters in the western part of the Nepal. And we also have discovered one natural gas in the western part of Nepal. So we are using these DGPS and drones. We are using this the drone also to acquire the data. So in some areas we are using a drone to get the data and then later converting into the micro topography. Drone monitoring is we are using in mines monitoring also. So recently we have completed this LiDAR survey for hyperstructural mapping. And Department of Mines and Geology is all responsible for all kind of this seismic monitoring and research center we have established here. You know that there is a seismic gap in the western part of Nepal, and we have a big challenge. We are in a 11th position because of the earthquakes risk. So we have 16 short period station and 26 broadband station. We have 51 CGPS, 30 and 36 accelerometer stations, and we regularly monitor and we provide information to all the concerned organization, local people. They can access, they can get from this data from our center, and we have been recording up to the 2 magnitude earthquakes. So these are the achievements we have achieved. So some of the geological maps, geoscientific understanding of complex geology of Nepal Himalaya, and supported government for disaster preparedness, some seismic hazard. We have produced some seismic hazard map, landslide hazard map. We have been providing regulating mines and mining and quarrying. And also because of the mining exploration activities, several mining industry has been established. And DMG is also responsible for formulating mining law and other policy things. So we obviously have several challenges because Department of Mines and Geology, we only have one office in the central region. We need to have more expertise, more technical manpower, and we need more budget and research labs, etc. And we have not still covered the whole area of Nepal for geological mapping, hazard mapping, and other things, and even for the mineral exploration also. So we also have challenges with integration with other agency. For example, I have seen before our Secretary of Physical Infrastructure here, we don't have any geologist in road department. We have been asking them to create a job position there. So you see a lot of,
Yeah.
so I'm sorry to say that, you know. So as our secretary promised before, maybe he can initiate this from his trainer, you know. So these are the things we are facing, you know. So Department of Mines and Geology is the only one organization where we are working on in this phase.
Okay, so could you please finish now? The time is over, please.
Oh, this is the conclusion. I'm not
yeah,
going to read it.
Yeah.
Thank you very much.
Okay, thank you very much. Thank you, Mr. Dinesh Kumar, for your very excellent presentation, especially on the role of Department of Mines here in Nepal. So please welcome our next speaker. Our next speaker is Professor Shuchi Hasigawa and Ranjan Kumar Dahal. Professor Hasigawa will talk the title of his presentation is The Significance of Dissected Deep-Seated Landslide Topography and Hydrothermal Alteration in Active Mountain Belts. Please welcome Professor Hasigawa Sensei. Yeah, thank you very much. Yeah.
Thank you, Professor Sai. I'm Shuchi Hasegawa from Kaga University. Kaga University co-organizer this significant conference. I'm very happy to honored to present a keynote lecture at a very important conference. My co-presenter is Dr. Ranjan Kumar Dahal of Tribhuvan University. He is very busy because he is a convener of this conference. Now, my first visit to Nepal is 23rd. In 25th, Dr. Ranjan Kumar entered Kaga University as a PhD student. After that, we pursued collaborative work on engineering geology in Shikoku and in Nepal. So this is my presentation is basically I have learned and Dr. Ranjan Kumar Dahal learned from the engineering geology in Japan, but it is very it is effectively applied to Nepal Himalaya. Don't move. Can you go? Doesn't move. Doesn't work. Can you help me? sorry. Aim of our presentation is first to provide a background and characteristic of topography and geology of Himalaya and Shikoku in Japan. Second, to provide the engineering geological issues on hydrothermal alteration due to the Miocene volcanism. Third, to provide the engineering geological issues on large-scale dissected landslide topography. The lesson from Shikoku Island, Japan, can effectively apply to Himalayas. This map shows the tectonic setting of Himalayas and Japanese arcs. Japan is situated over the subduction zone of Pacific and Philippine Sea plates under the Eurasian plate. The Himalayas are situated over the collision zone of Indian plate under Eurasian plate. In spite of the different tectonic setting, the Himalaya and Southwest Japan have a similar engineering geological issues. Yeah, as you know, Japan is an earthquake country, and subduction of Pacific and Philippine Sea plates are the main force of earthquakes, volcanism, and mountain building in this area. Japan has suffered great damage from massive intraplate earthquakes produced by plate subduction, such as the 2011 Tohoku earthquake and island cluster earthquakes caused by active faults, such as 1995 Kobe earthquake. Himalaya has suffered great damage from the massive interplate earthquake caused by plate subduction. 2015 Gorka earthquake and aftershock was caused by plate subduction. In spite of the different tectonic setting, Himalaya and Southwest Japan has a similar topographic profiles. Higher Himalaya and lesser Himalaya is correlated to Shikoku Mountains. So the similarity between Shikoku Mountains and Nepal Himalayas as follows. First, Miocene granitic granite are distributed in higher mountain area. Uplift of mountains are closely related to Miocene granite. Hot water spring in non-volcanic region. And hydrothermal alteration as one of the geological factors of deep-seated landslide. This image shows a geological map of Southwest Japan. Southwest Japan is divided into Ryoke Belt and Sambagawa Chichibu Shimanto Belt by the median tectonic line, one of the most active faults in Japan. And highest mountain peak and hot spring in the outer far side of Southwest Japan are closely related to Miocene granitic rocks. This shows a geologic cross-section of Southwest Japan. Southwest Japan were formed during the subduction tectonism, which include both the formation of accumulation of prism and the intrusion of granite. Although Shikoku is located in quaternary non-volcanic region, the Miocene granitic basalts and Mesozoic the Miocene granite beneath the Mesozoic and Paleozoic actionary prisms have played important roles in mountain building and engineering geology. This figure shows the highest mountain and hot spring in Hoak side of southwest Japan, and closely related to Miocene granite. Hot spring in Kii attained almost 19 degrees Celsius, very hot. And ore deposit, another evidence from Miocene hydrothermal alteration is ore deposit. Ore deposit originated from shallow hydrothermal alteration during after Miocene granite intrusion are widely distributed in Shikoku, especially along the median tectonic line. Yeah, let's talk about the case study in Shikoku. The MTL marks a striking contrast in topography between mountains and alluvial plain in Shikoku, southwest Japan. MTL is a predominant active fault and hydrothermal alteration zone. Notice the sign of hydrothermal alteration in volcanic, non-volcanic region is our lessons. Yeah, landslide occurs at large-scale cut slope of highway in large scale near the median tectonic line in Shikoku. Slip surface is composed of smectite-bearing clay originated from hydrothermal alteration due to Miocene rhyolitic intrusion. Cation exchange capacity (CEC) test and X-ray diffraction data of smectite suggests that exchange cation is mostly calcium and assessed as calcium type smectite, which has swelling potential slightly smaller than that of natrium type. And it is important detect the hydrothermal zone by remote sensing. Helicopter-borne electromagnetic method is very useful for detecting clay-rich hydrothermal alteration zone as a low density zone. Large-scale landslide topography is closely related to low density zone and along the MTL. Okay. Hi. Yes, thank you. Relation between formative age and degree dissection of large-scale landslide topography in Japan suggests that topography of large-scale landslide have been completely dissected in 1 million years. So the landslide formed before 1 million years, 1 million years is no topographic characteristic. But we try to characterize this dissective landslide topography. Yeah, here we show the example of dissective landslide here along the active fault of the MTL. Kirihata Hill is a dissective landslide hill which was formed about 1 million years and have placed right laterally 2 or 3 kilometers. The rock mass is completely fractured with the alteration of sandstone mudstone in Sanuki mountain range. After that, we propose the criteria of recognition of dissected landslide topography. Criteria for recognition of dissected landslide topography is most important criteria is discontinuity of ridge. We judge the whether this ridge is connecting or disconnecting is a very important point using this red relief map produced by Dr. Chiba, Asia COSOP. So the second criteria is lower elevation of separate slope. It is natural. So mass movement, downslope movement. So the mass becomes low level. And third criteria is gentle slope, because if the mountain slide, they are spreading, so the slope becomes gentle. This is three criteria is very useful of recognizing dissected landslide topography. With this technique, we analyze, we try to find the dissected landslide topography. The dissected land topography is concentrated along the median tectonic line. And a very interesting finding is new landslide, large-scale landslide topography was not formed on dissected large-scale landslide topography. It means large-scale dissected landslide mass act as a cushion during earthquake caused by faulting of median tectonic line. This figure shows the H/V spectrum by microtremor observation. The Sanuki range is composed of sound rock mass of of sandstone and mudstone. They don't have a predominant frequency. At Kirihat, on the Kirihat Hills, the H/V spectrum have a predominant frequency around 2 to 1.2, 1.6 hertz, kilohertz. And also on the Yoshino River basin, in the flat plain, where the thick sediment is confirmed by boring and seismic reflection survey, predominant frequency about 1.3 hertz. So, how to interpret this phenomena? Usually, is bedrock has no predominant frequency. This is our interpretation, my interpretation, that Kirihata is isolated here, caused by the ancient large-scale landslide, is sitting on the thick quaternary sediment. This figure is, I imagine about 13 years ago. So that many tunnels is constructed along the median technical line in Shikoku. But during the tunnel construction, the lithology is not effective for rock mass grading. Sandstone is not good, but mudstone is a little better. So we planned the tunnel ground is classified 4 types. First criteria is they suffered landslide or sound stable mountain. Second is evidence of hydrothermal alteration. We classified 4 types of tunnel ground. So N type is very good, good tunnel grade, and S type is bad tunnel, worst tunnel grade, and H type is most worst type. HS type is worst. But surprising fact is observation of inversion during tunneling. H type, hydrothermal alteration type, and HS type, hydrothermal alteration and then landsliding is worst and worst ground type. And moreover, acid hydrothermal alteration due to middle Miocene volcanism also produce a cave in limestone. Let's apply to Himalaya. The important fact is Miocene leucogranite is distributed in higher Himalaya. And hot spring is located near higher Himalaya along the MCT or other fault. And in lesser Himalaya, we have evidence of hydrothermal alteration. Beautiful quartz mineral is obtained from this outcrop, this boulder. This boulder suffers hydrothermal alteration in Middle Miocene. It related to gold ore deposit. About 20 years ago, I and Ranger-san write a paper on the geological cause of deep-sea landslide in the Himalaya. The clayey layer along the sliding surface is originally formed by hydrothermal alteration. Hydrothermal alteration related to Miocene volcanism. Yeah, let's talk about Kathmandu Valley. Kathmandu Valley is a very abnormal valley. It's not valley for me. It is highland for me. And how Kathmandu Valley had been formed. I have a hypothesis of ancient large-scale mountain slide at west and east part of Kathmandu Valley. This continuity of ridge around Nagarkot shows the ridge. There are many dissective landslide topography. The rock is very disturbed and brecciated. That means the ridge is not stable ridge. The western part of Kathmandu Valley, there are two mega ancient landslide mass. This is my hypothesis. And second stage mega landslide is like this. At this hill, Nagadunga Tunnel was constructed, and I have confirmed the rock mass is highly cracky and brecciated.
Hello,
Deep sea
Professor
ejaculate.
Hasegawa.
Yeah.
Yeah,
Okay.
yes, yeah,
Sorry.
yeah. Sorry for that, yeah.
Yeah.
Sorry
Yeah.
for that.
And the intense factor during Gorka earthquake in Midland, we have a few landslides. Higher Himalaya has a very steep slope and hard rock compared with Midland. So I have a hypothesis. This hill was a landslide origin. At the western end of this hill, Suyanabut hill is located. This shows the destruction of brick house in the Sound Ridge. Center is collapse of brick house and collapse of tall tower, but brick house, the fragile brick houses remain. On the hill of Monkey Temple, same thing happened. Tower is collapsed, but fragile brick houses remain. Monkey Temple is located in Kathmandu, on the thick Kathmandu Valley. We don't think so. It's on the bedrock, but is truly bedrock? We think this is not bedrock. This is one sliding block, like iceberg. We call it rockberg. So this is concluding remarks. The hydrothermal alteration and dissective landslide topography is very important in active mountain region. And this finding in Japan is effectively applicable to Nepal. Thank you.
Thank you. Please give it a big clap. So thank you, Professor Hasegawa, for your very informative and nice presentation on the significance of the deep-seated landslide topography of the active mountain belts. So thank you very much. And now we'll proceed for the next presenter. Actually, there will be rearrangement of the presenter here. At this moment, the Keshav Kumar Sharma will present, Mr. Keshav Kumar Sharma will present his talk on the slope stability and resilient roads in the Himalayas. Please welcome Mr. Keshav Kumar Sharma. Please welcome him. Again, I would like to request our presenter, please you try to maintain the time because still we are far behind from our main schedule, so please try to keep the time. Yeah.
Thank you. Good afternoon to all. I will present slope stability and resilient roads in the Himalaya, Nepal's challenges and initiatives, with a case of Naranghat-Kathmandu road section. My presentation subtopics will be Nepal's transport infrastructure development, status of transport modes, challenges for sustainable roads, government's attempt for sustainability in road infrastructure, and multi-hazard analysis of Naranghat-Muglin Road. This is the road development scenario, transport development scenario of Nepal, initiated with, nowadays we ride the cars. In the beginning, we carry the cars by men. So this is the photographs on the left corner. And there was a train service actually built to transport the timber, wood from Nepal's dense forest to East India Company. This is the railway. Then we had a tunnel. Probably it is one of the ancient tunnel in Asia. South Asia could be the first road tunnel. And then ropeways, and in 1953, we started building Tribhuvan Highway that links Kathmandu to border of India, Raksul. So nowadays we have 80 national highways, provincial and local roads, air transport, 3 international airports, 51 kilometer railway in operation, ropeway, waterways, and it is about 100,000 kilometers roads in the country. This is the road development scenario since 1980 to 2020. In 2024, we have now reached almost 100,000 kilometers of roads, but all-weather roads are only 1/3 of the total road. It is because of the landslides, because of the earthen roads. Most of the rural and provincial roads are urban, and because of landslide, this cannot serve all weather. So what is the challenges? In road infrastructure, the main challenge is our geology, young geology and steep slopes, climate change, which creates, in combination of the geological condition and climate change, landslide, flood, then engineered roads in the rural areas, especially without proper study of environmental study, roads are being built, local roads, so this is also a challenge. So Nepal's vulnerability, my previous presenters also highlighted, we are in the very vulnerable zone. Disaster vulnerability of Nepal is, for climate change, it is 4th, earthquake is 11th, flood 30th, landslide 7th. Landslide, based on proportion of population affected, is quite higher. This is in the first rank, and overall disaster is 20th. One of the reasons for our landslide is rainfall intensity. The annual rainfall happens in Nepal within 3 months narrow period of monsoon. Almost 80% of the rainfall happens in the monsoon, that is June to August. So if we compare the rainfall pattern in Thailand and Nepal is the left one. It is because of the intensive rainfall during monsoon season, slope instability happens here. So this is the landslide. We are in the landslide prone zone. Many fault zones are here, and even MBT passes through Nepal. So the landslide, similar landslide, we have also the earthquake vulnerability. The picture is from Gorkha earthquake in Gorkha district, and other rainfalls, other slides in roads are common for the hill roads. This is the flooding because of rainfall. So these are our challenges. Earthquake also, many road infrastructures are being affected by the earthquakes. The Gorkha earthquake 2015 was devastating, and similarly the local earthquake, Jajarkot earthquake in 2023 also affected many road infrastructures. Another challenge for Nepal is Gulf. This is glacier outburst. The Thame glacier outburst last year was devastating. And also this year, 2025 also, there was a glacier outburst in Tibet region, but Nepal's highway, bridges and highways were affected in Rasua district. So what is the initiatives the government of Nepal, especially the Ministry of Physical Infrastructure and Transport is being carried out? Is Nepal's road standard we have revised to accommodate the climate change scenario, stage construction guideline for roads, bioengineering, manual guideline for road slopes, river side road alignment design guideline, river training manuals, road closure and status apps. And similarly, we are now coordinating with the Department of Hydrology and Meteorology for the design and maintenance of our road infrastructures, their forecast and their data for design and maintenance of our infrastructure. Similarly, we are moving towards tunnel. Just before this presentation, we have seen the Nagdunga tunnel. We are also constructing Siddhababa tunnel in Siddharth Highway and many other tunnels. We have the feasibility study report and design reports which are in pipeline. So these are some photographs what we are doing at the field for slope stability. This is disaster. Then after we use bioengineering, rock nailing, netting. With various interventions, we are trying to stabilize our roadside slopes. Here, I would like to present one research work was carried out by myself, and co-authors are Professor Bhandari from EME University, Japan, Dr. Mandip Subedi from Universal College, and Rajan Keshi from Geo Infra Research Institute. We had conducted one study for the Naran Ghat Kathmandu road section. This is the main backbone of our transportation system to link Kathmandu with other parts of the country as well as with the Indian cities. So this is the study area from Kathmandu to Naran Ghat. This road is very busiest roads in Nepal, and this passes through basically the hilly area with Trishuli River bank, along the Trishuli River bank. So there is a threat of both landslide and undercutting from the river. This is the flow chart of the study, how we conducted. This is the findings from the study. We had taken 11 factors for slope failure. Different factors with the different factors, we have found the results. The red one is the worst one, severe, and the green is the normal. I will briefly explain the factors in coming slides. This is from we have divided the roads in 3 segments: Naranghat to Muglin, Muglin to Naubise, and Naubise to Kathmandu as their alignments situation. This is Naubise to Kathmandu. So the factors are the most affecting factor for landslide susceptibility assessment. We found the slope is the in first rank, then annual rainfall of that area, then this proximity to stream undercutting, then the vegetative cover, land use, and the geology. These are the most affecting factor for slope failure in this whole road stretch, that is 146 kilometers. This is the map of entire study. This shows from Gaighat, that is 18 kilometers from Muglin, from Naranghat to Kurintar, 9 kilometers towards Kathmandu. This section is most vulnerable for landslide. This is the vulnerability for road infrastructures. We have taken, for road infrastructure, we assessed only 36 kilometers from Naranghat to Muglin because another section is now being upgraded. The old structures are being dismantled and new structures are being constructed. So we had examined, we had analyzed only the structures, road structure along Muglin to Muglin Naranghat section, that is 36 kilometers, and the structure vulnerability is shown in this map. The risk we have found is in entire 146 kilometer, landslide risk is 12% area is in very high landslide susceptibility area class, 40% high, 42% is moderate, and only 6% is low. That means this road section is very much susceptible to the landslide. For the Muglin Naranghat roads, 5 bridges, 21 culverts, and 15 retaining walls are in very high risk zones. So the department, ministry should give proper attention to enrich, to strengthen those structures. These findings emphasize the exposure of the road network, landslide hazard, and underscore the importance of targeted intervention to enhance the resilience of road infrastructures. So our study recommends the transportation planners and policymakers to mitigate the landslide impacts on road infrastructure, improve safety, and enhance the reliability of transportation routes in mountain areas. Okay. What would be the way forward? So enhancing slope stability and resilience of road infrastructure in hilly regions requires a system-oriented approach grounded in geological understanding, climate adaptation, engineering innovation, and institutional coordination. Regarding this institutional coordination, one of my colleague from Department of Mines, the previous presenter, had a query that position of geologist in the Department of Roads, we have already created a position of geologist in our department, but the challenge is to retain them. They are not that much interested in working. This is the different department, right? This is a heavy domination of the road engineers, so geologists are one or two. So anyway, we have already initiated.
Okay.
Because this is the geology is one of the effective factor in challenge for our slope stability. So it is our finding also. So we are
Okay. Yeah.
we are already initiated, and if necessary, we will going to extend the positions. The integration of geotechnical science, spatial risk assessment, context-sensitive engineering, and proactive policy frameworks offer a pathway towards safer, reliable, and climate-resilient road network in the Himalayan region. These efforts supports Nepal's broader objective of regional accessibility, inclusive development, and disaster risk.
Okay,
reduction.
thank you very much. Thank
Yeah.
you, Mr. Keshav Kumar Sharma, for his very time-benefiting topic regarding the infrastructure, especially road network in the Nepal Himalaya. So
Thank you.
we enjoyed very nice. Please give a big clap to our honorable speaker. Thank you very much. Thank you very much. Now our next, we are delayed. I think the lunch will also be delayed because of the late start of the session. So next presenter is the Tilok Nath Singh. Mr. Tilok Nath Singh, could you please come and present here? Yeah, thank you very much. So again, my request is because everybody is waiting for lunch. So if you skip some of the slides to finish timely, that will be better for us to join the lunch. Thank you very much.
Thank you, Mr. Chairman, respected audience. From morning, we have different topics related to disasters and application of engineering geology in the various fields. We have in the keynote also, we have the lectures related to the tunneling, earthquake trigger landslide, slope stability. Now, I am coming a little bit ahead of that. I am giving you some glimpses related to the rockfall problems associated it. Mainly, the previous speaker has spoken about the road construction in the hilly region. Rockfall problem is very, very naturally occurring process once we are going to have the development of roads in the hilly region, cutting across the various kinds of rock types. And sometimes it is not possible due to the economics, due to the technological detail, that we can cross this road, disturbing the whole strata with this height is increasing or decreasing. So this is the one of the classical example. And Mr. Chairman, I will abide by your instruction. So go a little bit faster because rockfall always have this high momentum and speed. So as you know, this once you have the rockfall, why it is something different from the landslide? Mostly in the landslide, the total mass is moving across the slope and having some kind of vulnerable rock, geological discontinuities. But sometimes you will see that the total entire rock mass seems to be very, very stable. And even in negative slope, it is stable. But there are certain locations and patches where discontinuity control the stability, what we discussed in the very first lecture about the kinematic analysis. The reach of that place is also very, very difficult. And then we have to analyze sector-wise, not the total rock mass. Once you can deal the entire slope, your factor of safety is very, very high because rock contains lot of this hard rock, monolithic rock, and so on and so forth. So this is the study area probably from this Himachal Pradesh of India. And here we have applied some of these numerical tools and the technique for getting some information that how rockfall occurred and what are the preventive measures on that one. So we have used numerical analysis, mostly this IAEG program software we have used, where the combination of these two finite element and finite difference coming together and how we can work on that one. So that will be and mostly how to simulate this total structure, including all the geological defects and discontinuity within this rock mass. That will be the greater challenge, because if you can miss any one of this geological discontinuity, that might we have to pay a heavy cost of that one. So we have used, I told you, the software which is readily available, and it will be the mostly 2 to 3 dimensional software. So I'm just leaving this part because it is all known to you. So this is the study area. Mostly you can see this study area is in the high hills of this Himachal Pradesh. It is a national highway of India 205, and it is in Kinnaur district. And Kinnaur is very famous because of its altitude and number of places. Once you can come across to this border area, you will find a different kind of rock type, and different places you have the rock shooting area. Rocks falls slowly and this road is closed for a longer period of time. So that will be the area which we have taken. If you can look at this rock type is very, very competent rock as per this RMR or Q or any kind of this SMR rating. These rocks are very hard. Compressive strength is about the 70 to 80 megapascal. And very CN5 value because it is a quartzite of nature. But there is a seepage and this making in the damping in the nature. So what we have done, we have collected the samples from this rock site, from the actual site. It will be tested as per the requirement of this input data required. So we have taken all kind of this jointing pattern, their spacing, their aperture, their filling material, all the jointing parameters to find out the weakening coefficient of the rock, so that in the real situation we cannot simulate the rock sample strength, rather than we can use the rock mass strength. So weakening coefficient can be used to multiply, and then we can get a rock mass strength. So this will be the, just you can see this figure will clearly indicate you that how this rock joints, and this is the half tunnel, unsupported tunnel from a longer period of time, but it is started with the time frame giving some kind of the difficulty in that region, and lot of vehicles are passing across that one, and this is the overhanging. So what will be the solution of this area that we have tried to understand and then to suggest? The various rock mass parameters and jointing parameters is already given on this chart, which you can see. A distinct 3 sets of joint has been observed. This is the, you can see this, what happened to this rock fall. It doesn't allow people to come out. And this is the last year figure. So we have started this modeling method. As you know, the modeling having this certain limitation. And some limitation we have adopted also to make a solution. So we have tried to include this velocity, displacement, and acceleration within this model. Okay, just this is the, you can say this, how we can make this area. If you remember this, my previous field photograph, we tried to replicate all this by making this different kind of mesh out of that. And this meshing will help us to go more closer to this real time solution of that one. And this is the, all three joints has been taken into account. And we have identified through the kinematic analysis and presence of the joints that which block is the key block. And because you know in the slope stability there is a one type of failure is known as a key block failure. If you can disturb that key, the whole equilibrium will and isotachy will get disturbed and rocks will be start falling or getting damaged. So here also the key block has been identified which takes the control of all kind of the failure, and that will be this our central point of discussion and analysis. So the maximum velocity along the initial falling block has been taken into the consideration because you know there is a fall, flow, and slide. So in the fall, we have to think about this acceleration, velocity, and the size and geometry of the block. A different size of this block having the different kind of the dimension, and once they are hitting the ground, there is a bounce height will be also different. So coefficient of restoration is very, very important and key parameters once you are going for the rockfall analysis rather than the C and phi value of this material. So restoration coefficients had been calculated in the laboratory and then we have tried to find out a dimensions of the block. So exactly we have taken this equal dimension of this block and then try to simulate, and just you can see this is the another picture which shows this real dimension of the geometry of the fastest falling block, and all the dimension we have missed there. And what I have discussed in earlier about the key block, and this is the dimension of the key block of that size. Okay. So just straight we're going to the result. You can see this how this rock is started falling due to the velocity and this block movement. So this will compared not with the time, because we have done we have started that how the time and which time will come, but here time will not taken much attention. So you can see here this variation of the horizontal and vertical velocity value of the falling block with the number of calculated cycles. So this is the velocity versus the step at different steps, and you can see how this material is falling on this one. So both these things can be taken. So approximately the total cycle we have allowed to work is more than 61,000. So because you know it is a very time-taking simulation, and if I can go for more, then more time will required. So almost we have reduced this velocity up to 0 once this material is falling, and this about this speed is about 11 to 12 meter per second. Here you know this there is a two type of energy, the kinetic and potential energy. Once you are trying to make any kind of this rockfall protection, so kinetic and potential energy both is required, as well as the bounce out of this material. So the total energy calculated is about 49.8 kilojoule. So this is the maximum kinetic energy. So any material, if you want to put for the protection of this rockfall, the material should have 1.5 times more absorption capacity of this maximum kinetic energy. So your wire mesh or any kind of the net or the barrier, the tensile strength must be higher than that, because then only you can arrest the block at the site at the location. If you can fail or if you can change anything less, then there is a possibility of collapse. And we have the experience from the tunneling that you are not giving adequate support to prevent this rockfall or to arrest the rockfall at the site, then there is a collapse, either collapse in any kind of this devastating, because we have seen in this Atal tunnel in again Himachal Pradesh, the rocks are flowing just like a mud flow. This rock was so much crashed due to the highest stress that the whole material is flowing just like a water is flowing in a river or canal. So that much higher stress. So this is the region we have to be very, very particular about this impact energy and the kinetic energy of that area. So this will be the variation of kinetic energy of the falling block. We have plotted whatever this, I have given you this attrition, how much we have given, and how much energy is coming out of that. Just you can see here, we have further increased that what will happen once you can increase the number of iteration, and we have crossed that one. Earlier was near about the 61,000, it is going to the more than lakh. And you can see the entire overhang material with the, if you can compare with the time, now it has enough time has passed for the self-supporting. It was not supported at all by any means, but it is a more than 70, 80-year-old half tunnel. So now the time has come that it is losing its self-supporting time according to what we said is the RMR of the Benevsky 1974 or Q of this Barton in 1975 or even the stress-free Q number of 2000. So all this has been, we have started, and everyone is giving indication and supporting what the numerical analysis says. So that will be the nutshell, the conclusion of this total entire work. And you can see once you have increased 2 lakhs, and what will happen to this entire material is coming. And after that we have seen that once the overhang is slide, the rest of the material have a different kind of failure that will be mostly the planar failure. So along this one joint plane, whole of the material is trying to slide because the interface material is this siliceous material, and once the water is coming to that, it is providing a slip surface along the jointing plane. So that has to be taken into account, but once they start falling, and it has already started falling few blocks, so this will be the alarming situation, and we have to see how one can go ahead. The time is also, some time is given, so you can see the trajectory of this rock fall once we have calculated, and all this energy. Further, if you can see, once you can start this more number of cycle, the kinetic energy is reduced. Earlier, the kinetic energy which we have reported is near about the 49.6. Now it has been further reduced to 28.1 kilojoule. So because this overhang has reduced this overbundle rho, and this, if you can, simple physics, rho g h you can apply, this h has been reduced because of this overhang of the material, and the what we call is the half tunnel. So horizontal distance is very, very important. Once the rock will fall, where it will go? Because one side you have a typically high hills, another side you have the deeper valley. And if you cannot control these blocks falling within the road, if it is passing through the valley, it may hit somebody which will be going across that, or some of the hutment or some of the villages on that one. And there are many examples where people have lost their life due to this hitting of this block in the valley side. And people are unaware where it will be coming. Because these are the typical scenario. It looks like if you have a little bit of the mining, if you can do the blasting, and if you cannot control the fly rock within your permissible limit, this fly rock will be hitting even in a kilometer area. A simple block of the few millimeter or centimeter can make a life hell where there is hitting because of the momentum. So these are the things very, very important, and you can think about it. And this is the total the variation of kinetic energy along the slope, which this value is going about the 20.7 meter. So more than 21 meter it will be traveling in the horizontal direction. And this is the comparison of this total rockfall iteration, what we have made it. And based on that, we have suggested some of this remedial measure, because there are certain standard material is available, provided by many international company about the rockfall, those who are designing the rockfall barrier, and they have the rock crush methods. So these are the things which are very small work, but because why it is important? Because it is a lifeline of this Himachal Pradesh going to Kinnaur district to coming to this mainland. And thank you very much. And this work is done by some of my students who are working in the different university and institution. And I'm thankful for the organizers who has given me this opportunity to present my simple work of my student. Thank you very much.
Thank you very much. Thank you very much for nice completion. So now we have only one speaker. That one is on the geological environment and geohazards in the Qinghai Jiang Plateau, China. That will be presented by Professor Xiangwen Kui. Xiangwen Kui, please. Please welcome Professor Xiangwen Kui.
Ladies and gentlemen, good afternoon. I'm from Institute of Geology, Chinese Academy Science. I'm studying here, give lecture for my groups. My speak title, Geological Environment and Geohazards in the Qinghai Tibet Plateau. Next. This one. 4 parts. The first part is the second. I give a brief introduction about the second Tibet Plateau scientific expedition. You can see here the Qinghai Tibet Plateau from the Pamir Plateau and Hindu Kush in the west to the Henduan Mountain in the east, bordered by the Kunlun Mountain and the Qilian Mountain in the north and the Himalaya in the south, covers an area about 2.57 million square kilometers, with an average mean elevation 4,000 meters, over 4,000 meters. The change in this area has a direct impact on the living environment of more than 2 million people from the near countries. So the first scientific expedition project from 1951, 2 scientific expeditions led by Professor Deep and Shi Yafeng, and also Liu Tusheng from my institute, launched the first scientific expedition, covers 2.5 million square kilometers. And I skip this one. There are many achievements of the first Qinghai Tibet Plate expedition. Today I will introduce the second scientific expedition project on the Qinghai Tibet Plateau. It launched on August 19th, 2017. This task mainly strive to solve the problems of resource and environment carrying capacity, disaster risks, and green development pathways on the Qinghai Tibet Plateau. These include 10 tasks. Today I introduce the number 9, geological environment as geohazards. The main objective is to clarify the background of geohazard, and clarify geohazard laws, predict geohazard risks, and ensure the safety of engineering construction, living environment, and ecological barriers. We have investigated 6 hazards, include seismic hazards, debris flow disasters, mountain flood disasters, engineering disturbed disasters, and freeze soil disasters, and comprehensive disasters. And also we include a geological hazard and ecological risk assessment along a highway corridor. It is well known Qinghai Tibet area is famous for tectonic activity due to the collision between India and Asia plates. Neotectonic and seismic activity are active. Fractures are densely developed. From the right figure, you can see the GPS velocity indicates that there is strong crust shortening, crust deformation rates up to 40 millimeters per year. This is the terrain. You can see the several change in terrain. That means that the terrain fluctuates gradually. And strong river incision, large relative heat difference, steep slopes and deep valleys. Also, you can see the climate change amplifies in this area. The 4 figures shows the average annual temperature in the Qinghai Tibet Plateau, shows a clearly warming trend with a 50 years climate tendency rates about 0.3 centigrade 10 year. Annual precipitation on this area about 3.8 to 12 millimeters 10 year. And the fourth, the Qinghai Tibet also is a natural museum and a natural laboratory for the studied hazards. You can see here many kinds of disasters, earthquake, and debris flow, as I mentioned before. And also, this is shown a typical disaster events. We have recorded 11 earthquakes with magnitude over 7 occurred in this area in the past 25 years. And 3 years ago, on January 18th, earthquake occurred, caused the damage of the Xinjiang high-speed railway, causing some lines stopped. In Zhangye city, about 50,000 people were affected by the disaster. And the debris flow in Pelun Gully. And also the Bega landslide dammed 2 times in 1 month, dammed the Jingsha River and caused a serious loss. And move to the second, the geohazards in the Tibet, in the Qinghai Tibet Plateau. The first, the scientific expedition has given a comprehensive database of the geological environment and the multi-hazards of the plateau. You can see if you are interested in the figure, you can download from the net. We have shared the database. And also the distribution. We investigate the strong earthquakes in the Tibet Plateau. You can see the strong earthquakes occurred along the and controlled by the overall movement and deformation of active blocks with 80% of strong earthquake occurred in the boundary zone of the blocks. And we also investigated the debris flow. You can see here, 24,000 debris flow mainly occurred in the abrupt topographic change area and formed a belt-like pattern along river. And under the condition of climate, you can see increased glacial runoff at frequent extreme. Flash flood events. At the edge of the Qinghai Tibet Plateau, at the middle and lower reach of the Yajiang River Valley, especially in the transition zone between the first and second terrain step in the east region, prone to the flash flood. And the distribution of the thermocast landslide. Thermocast landslide mainly occurred in the permafrost region of the central plateau, increased by 41 and 43 times over the past 50 years. Thermocast landslide are projected to keep increasing, with estimated annual rise 80 events. And also, we invested the GLOFs, the glacial lake outburst floods, induced by climate change. Since the 20th century, 113 glacial lakes in the Himalaya region have experienced 249 outburst events, and they mainly occurred in the river Nik zone. And the climate change has led to an increase in the frequency of avalanche, snow avalanche, triggered by the heavy snowfall, and at a rate of 0.60 events per decade. And the distribution pattern of major engineered disturbance disasters on the Qinghai Tibet Plateau. We investigated the surface engineered disturbance disasters, mainly occurred in a larger elevation difference, steep slopes, and high rainfall, frequent strong earthquakes, and heavy rains also caused the southwest Yunnan province, lead to a high density of disasters. And also, we investigated underground engineering disasters. We found that it mainly occurred in the tectonic zone along block boundary. The green point has shown that. We would like to skip this one. We also investigated the impact of major engineering on hazards on the Qinghai Tibet Plateau. We found that the disaster design density is negatively correlated with the distance to dead water level at the road, occurring within 800 meters. And we found reservoir-induced landslide mainly developed during the first 3 to 4 years after reservoir impoundment, gradually stabilizing after reservoir normal operation. So we also skip the third part, formation of the geohazards in the Qinghai Tibet Plateau. We clarified eudogenetic dynamic dust forming mechanism driven by the plate closure. We can see the Himalaya organic belt and the multiple suture zone control the internal dynamic force responsible for disaster occurrence. Disasters are densely distributed along the main ridge of the Himalaya, resist tectonic, resist syntax, and north-south rift valley at suture zone. Landslide prone strata controlled by the suture zone structures with boundary fault structure damage and dynamic metaforming, leading to the deterioration of the rock mass. The long-term accumulation of the internal stress within such zone, coupled with shear stress concentration along boundary faults and river erosion, controls the spatial temporal variation of slope stress. These processes intensify unloading, deformation, and the failure of the slope. And we also clarified the earthquake generation mechanism. The long-term multi-stage disaster-prone background formation process in the northern part of the plateau has been clarified. It has been reviewed northward expansion on the plateau and the limited eastward extrusion on Baja block and a dynamic mechanism, leading to the recent frequent earthquake occurred in this area. You can see the red star shows the points. And this shows the Tianshan area, the earthquake. The internal high angle sinistral shear along with thrust on both sides jointly regulates the tectonic deformation and the occurrence of the strong earthquakes occurred in the Tianshan region. And a new model proposed, a new model of orderly outward expansion in the northeast Tibet plateau during the latest Cenozoic has been proposed, forming a dual boundary for plateau expansion. This model controls the generation and occurrence of the main regional earthquakes. Their achievement has been published on many famous journals. If you are interested, you can download the paper. And the disaster development is controlled by the latitudinal variation of regional tectonic units formed by the collision of the India and the usual plate. You can see from the south to the profile, from the south to the north, you can see the low Himalaya, high Himalaya, Tethys Himalaya, and the Yakutsoppo, such zone. We can see that from the large elevation difference, the narrow valley, abundant rainfall, fractured and weak rock mass, strong seismic motion caused the medium to small scale shallow landslide debris occurred in the south area, south region, low Himalaya. But for the high Himalaya, large to giant deep-seated landslide, just as mentioned by Professor before, and large to giant glacial lake outburst at the ridge area, Gulf, mainly occurred in this area. And large to medium-sized topo bedding landslide occurred in the north. Large to medium-sized long roundlets occurred in the valley area. And multi-phase and multi-field coupled dynamic evolution mechanism of landslide debris flow on the Tibet plateau are clarified. And also we discovered that combined effect of tectonic, earthquake lithology, and climate primarily drive the formation and the evolution of large-scale, low-frequency debris flow. These findings review the source material control theory and explain the phenomenon of large-scale debris flow triggered by the low-intensity rainfall. And we also found the formation of the subsurface stone flow on steep, humid mountain slope caused the flash flood. And we also clarified phase separation caused by the freeze-thaw process of needle ice plays a critical role in shaping regular periglacial landform in this region. We skip this one, I skip this one because time is too limited. We don't want to make you hungry here. So we proposed a mutual feedback mechanism between major engineering project and the geological environment on the Tibet plateau. You can see here, we also clarified the dynamic mechanism of underground engineering disturbance disaster caused by the engineering excavations. You can see here the rock burst and also the large deformation. The last part, geohazard prediction and mitigation technology. First, we developed the disaster development trend and risk assessment. We predict the earthquake, strong earthquake, and the secondary disaster risk trend with the discontinuous deformation analysis method. So you can see the red point is the potential large earthquake occurred in the future. And also we built the prediction method and identified several debris flow gullies on the climate change. We don't want to introduce in detail. And the evolution trend and risk prediction of mountain flood disasters, and also the rainfall during the flood season and the risk prediction of mountain flood disaster on the Tibet Plateau. And we also clarified the national and the key regional mountain disaster prediction method serving the national disaster reduction deployment. And we based on the risk assessment of earthquake, geology, flash floods, and freeze thaw disasters, completed a comprehensive risk assessment in the whole Tibet area region. Okay. And the advanced identification method, such as for the intelligent remote sensing method, and we built advanced numerical simulation method, such as discrete element method for ice bodies, consider fragmentation and disintegration. And also the dynamic fragmentation, fluidization, and long-run landslide disaster chain, and the dynamic evolution model, and the landslide debris flow disaster chain, and the dynamic evolution process of the glacial lake outburst flood chain, and also the dynamic relation evolution process of landslide dam bridge flood. And we constructed a dynamic series of debris flow disaster chain, coupling with multi-phase media and multiple process. Constructed a multi-scale disaster risk assessment method based on the mechanism and the dynamic process of disaster formation you can see here. From the dynamic process, risk calculation elements, comprehensive risk. We also reviewed the dynamic disaster process of debris flow and the mechanism of interaction with the structured body. You can see with the bridges here, we show here. And the last one, we also built the monitoring and early warning technology in some area. For example, in the west syntax, the east syntax, we have built the monitoring and early warning technology to monitor the geohazards, such as earthquake and the debris flow, and also everything else. Thanks for contributions from all our members involved in this huge project. Thanks for your attention. Thanks.
Thank you very much, Xiangwen Tu, for your very informative presentation on this particular area. And we are still little bit, all of the keynote speakers helped me, just 6 presenters within 3 hours time, but we tried to finishing it within 2 hours, 50 minutes. That's why I'm extremely sorry, because the first session, it was too much delayed, and that's why this request every time to all of you. I'm sorry for that, as the lunch is waiting, so we have only one. Thank you. Please give a big clap to our speaker. So, and now, only 5 minutes before this GeoBark presentation, I'd like to request all our honorable keynote speakers, just wait 4 or 5 minutes to collect your, the team already supplied your certificate regarding your participation as a keynote speaker. I would like to request you, please wait after this one. We will just hand it over to you. Please wait a few minutes. Okay, now you can present. Yeah, thank you very much.
Thank you very much, and you don't have to be worried because mine will be very, very quickly.
Yeah.
So, my name is Dennis. I work for GeoBrook, a company based in Switzerland, and we are very honored to be the gold sponsors for this event. And therefore, I really want to welcome everybody to the 15th Asian Regional Conference of IAEG. And I hope that you will have a beautiful couple of days. Maybe you need to help me to start the video. Guys, can you help me to start the video? This is always difficult from this side. I don't want to bother you too much with products, presentations, and details. You can welcome to visit our booth outside. I just want to highlight two topics from this year from Geobrook side. First of all, in May we have been successfully testing a 12,500 kilojoule rockfall barrier in our test site in Switzerland. So just imagine 12,500 kilojoule being retained in a flexible rockfall barrier. So it's a 25 tons block who will be dropped into the barrier from 52 meters free fall. And I wouldn't show it to you if it would fail, of course. So this was one of the big achievements of Geobrook this year. But rockfall is not always happening just like we do in these tests, right? So I want to show you another video. You have to start it for me again. A second video, what we also did this year, was to do a simultaneous impact into a barrier. So you can see the same quarry test site like you have seen in the previous video. And we dropped two rocks or two boulders simultaneously into the retaining structure, into our flexible barrier. So we as Geobrook, we truly believe that we have to push innovation and we have to talk to the stakeholders and also be in close cooperation with the scientific community to push standards. At the moment, we are discussing with the certifying bodies in order to change rockfall testing standards to have a more realistic approach to actually what rockfall is doing to those retaining structures.
So finished. Thank you very much.
I have
one more?
I have 1.5 minutes left.
Oh, okay,
just start the video and I will just use the video. Can you kill the volume?
Okay, yeah. Okay.
I just want to use this video in the background to really thank everybody for coming here, for participating here. I think it's very, very important to have this exchange. Also, I want to express my gratitude and thankfulness to Dr. Ranjan and his team, because they had probably in the last couple of days sleepless nights to prepare everything of this. And therefore, I would like you all to give big applause to Dr. Ranjan and the local team. Thank you very much.
Yeah, thank you also Geobrook for to be a good sponsor and supporting us. Thank you very much. Thank you. Now I would like to request our honorable keynote speakers. Please, first I'd like to tell the name of Professor Bacillus Marinos. I am not sure is he. Oh yeah, he's here. Yeah. So we can hand it over to him. Take the another one. I'm calling Dinesh Kumar Napin. Please, could you please come to the dais? Just to connect. Oh, yeah, thank you very much. And our honorable next keynote speaker is just to give him later. And next one is the Professor Tiloknath Singh. Now our honorable speaker, Professor Tiloknath Singh from IAEG.
Thank you very much.
Yeah, thank you very much, Professor. So, one more, yeah. Yeah. Next one is for Professor Shang Wenkui from Chinese Academy of Sciences. I'd like to invite him to collect his certificate. Professor Shang Wenkui. Okay, thank you, Professor. Yeah, thank you very much. Thank you. So I finished?
Yeah, thank you so much from
Thank
the
you.
chair and the keynote speaker. Now I would like to request Professor Dr. Suichi Hasegawa to come on the stage and present the token of appreciation to our chair and co-chairs.
So thank you all. Now lunch will be served outside of this room. I am sorry for delay lunch. I am extremely sorry to all of you for delaying. Thank you very much.
Yeah,
Thank you.
please,
Have a nice lunch. Thank you very
I
much.
request everyone to
Bye-bye.
please show your name card so that you can get the lunch coupon outside. Thank you so much. The next session will start at 3 p.m.
attention, please. So we are now going to start our Women in Engineering Geology section, WEG session. Good afternoon, everyone. We are back again with our new technical session, Parallel Technical Session 1. The session theme is the role of women in the development of engineering geology. So to run this session, I'd like to first request a convener, Dr. Anne Williams, to convene this session. In addition to that, I'll also like to request Angela Babu Malla and Professor Tomei Khatuk to coordinate this session. So in this session, we total have 6 presentations, and then it will be followed by parallel panel discussion. So I'd like to hand over this to Dr. Anne Williams. Over to you.
Thank you. So it's my pleasure to, I wasn't sure which one was working. Thank you. Oh, this one's fine. So it's my pleasure to open this Women in Engineering Geology session in Kathmandu. I thought I'd just start off to explain, well, why is there a Women in Engineering Geology session? Why do we need to have such a thing? And really the background was when we started thinking about inclusion and the diversity of our organization, and we looked at ourselves 60 years on, and what is the role of women in our organization? We haven't ever had a female president. We've had, I think, 5 vice presidents. That might sound okay, but out of the 480 options of being a vice president over 60 years, 5 isn't really a great track record. And then we look at how women are involved in our conferences, and very often, if you look on LinkedIn, you'll see groups of men having a nice time at a conference. And so we wanted to sure that we are consciously including women in roles that matter in our organization, and then by extension in the industry, hopefully. So I guess on that note, I'll hand over to Professor Vasilis Marinos, who's our president of the IAEG, and he's going to say a few words about women in engineering geology. Thank you.
So I'll have the timekeeper here in my phone, not to mess with the WEG session. So first of all, I would like to give my appreciation to the Women in Engineering Geology Group and the ERC Organizing Committee for making this session, creating this platform that it will focus on inclusion and visibility. And we need to recognize that all this pioneering work of women in the past was not often recognized. You know, a lot of women that helped to shape the world of engineering geology did not get the recognition they deserved. So we definitely acknowledge now the strength of the WEG, of our Women in Engineering Geology, and the importance for these gender-focused initiatives within IAEG. This is very, very important for us. And you know, if we go back, because we need to go back, now in IAEG, we highlighted this importance for many, many years. I remember seeing Anne Williams as the only person in the council meetings, in these events for many, many years when I was growing. So this was really in IAEG community problematic. So with this WEG, we will see these visible options. So the historical contributions, we need to honor all these women that were in much more difficult situation than they are today. So you understand that going to work in the field work, in academia, in the industry, inside a tunnel that women were not supposed to enter, because for some people and the workers was bad luck. And all these steps, all this effort, all this great heart and willingness behind that, we need to highlight all these early women in engineering geology that contributed to all sectors of engineering geology, in landslide, in hazard mapping, in rock mechanics, in hydrogeology, environmental issues. So this is very, very important. And now we are happy in one point, seeing some visible opportunities. Of course, we're not satisfied yet, but we can see more women in research, as educators, project leaders, and government advisors, stronger international participation. Still, though, for example, I was in the FedEx Association meeting last month in India, and our table was occupied only by president, immediate past president, and general secretaries only by men. So we discussed about that, we highlighted that, and we really try to have a stronger international participation and collaboration, not only in IAEG, but also in the other sectors in geoengineering and in technical commissions, in IAEG congresses. So the establishment of this WEG from the previous executive office as, let's say, motion, but officially in this executive, it is a very powerful network for us to give them voice, providing mentorship and visibility. This is very, very important for us to give not only these kind of sessions, but also their active participation in all aspects, organization, presentation, research, scientific contribution. So these barriers related to career progression, there are still challenges for the women. And these fieldwork expectations and the work-life balance, the uneven support across regions, all these challenges, I really have listened in Africa, in the African Regional Conference this September, stories of very powerful, dynamic colleagues, women in Africa, trying to just describe their daily routine. And this was not only inspiring for all of us, their larger effort they are putting, what in comparison with our own not being in their position. So this strategic importance of women in engineering geology is very important for our profession. Broadening our perspectives, first of all. These diverse teams, they give better results. So this is something, let's say, to see it as a result. That when we have all the different opinions, all this gender diversity should be embraced and could be helpful in the decision-making process. And the community engagement and women professionals often lead outreach, education, community-based hazard management. All these are daily routine that we see. We need to highlight it. We need to promote it. And the role of IAEG and the current actions, we try to support the WEG with a budget and all our heart to promote more and more, not only financially, but encouraging representation in commissions, in scientific in keynotes, in organizing committees, where you see that there is still a gap to be filled. And inclusion of the gender diversity, it is a strategic priority for IAEG. It is definitely, and we have proved that with the ADI policy and the code of conduct. But let's not see that only as a gesture, but as a reality. And our future commitment is to targeted mentorship programs from seniors to younger people, and promote this gender balance panels, committees. It is very, very important. And, you know, we need to emphasize that this is not a symbolic gesture. So this is very, very important to understand that we don't need only the heart. My personal experience in my family is that I was raised from two powerful women, my mother and my grandmother, and all the dynamic I have, a lot of dynamic I have are from them. Independent if they are geologists or not, as a person. But also my colleagues in engineering geology are mostly, it happens to be my best colleagues coming from that environment. Colleagues that we were studying together, we were working together, and we have an equal working environment in all phases, from step one in describing a borehole, and then interpretation, and then when we decide what finally we will give as a result, and who will be representing the team in a meeting, also, this has been always equal. So this WEG group that we have, and this session is not just a symbolic gesture. It is fundamental to the strength, creativity, and resilience of our community, of our engineering geology community. And this I would like to encourage, not just to encourage, to call for all our colleagues to support all our younger and in any part, because this equality is not only many times in human, but we're talking about women here, but in any sections that we see somebody not giving the attention and the voice, and is not encouraged to do so, we should encourage all these people. And the women, we should encourage them, and we call for all our colleagues to actively support the women's career pathways. So we need to understand that for engineering geology to thrive, we must build a community where women are fully visible, fully valued, and fully empowered. And the future of engineering geology and IAEG, it is counting on that. And with that, I would like to thank again the organizers and formally open the WEG session. Thank you.
And just before we introduce our first speaker, I was having lunch just earlier out there, and Dr. Manoj Verman came up to me and he said that he had put together a magazine called Tunnel Times India, and it's been running for a year. Oh, this isn't it. Where are we? Could you just share that image, please? And the very first issue of Tunnel Times India was dedicated to women And I thought that was a brilliant cover. Really nice to see women featured in LinkedIn and in various posts and in the media, because I do feel that our young people feel that they can be what they can see. And so sharing these types of images and these types of stories is a fantastic way forward for our industry. And right now, Tumai will introduce our speaker.
Hello and namaste, everyone. I'm one of the coordinators of the session, and I would like to thank to you all who are interested in this WEC session. And our first speaker is, I'm sorry if I pronounce it wrong, but Dr. Sultana Nasrin Nuri. Yeah. Yeah, and I will introduce her a little bit to you before her presentation. She is the director at the Geological Survey of Bangladesh and leads the Geophysical Data Analysis branch. With 25 years of experience, she specializes in urban geology, environmental geology, and geophysical surveys. And she holds multiple postgraduate degrees, including a PhD from Monash University, focused on urban heat island mitigation. And her work includes groundbreaking projects in geophysical data analysis, subsurface modeling, and environmental studies. And she has contributed significantly to urban development and environmental mitigation in Bangladesh. And I think her presentation title is Quantitative Analysis of Greening for Sustainable City, and the floor is yours. Thank you very much.
Thank you very much. Good afternoon. Assalamu alaikum, everyone, and namaste also. I'm Sultana Nasrin Nuri, as our coordinator said. I'm very much thankful to WEC community to include me with them, and also to the organizing committee to give me a chance to present my work here. Thanks once again. Actually, I'm not I'm not working as truly engineering geology. I'm not going to present truly engineering geology work. Something that can support to the engineering geology, like sustainable development of a city. It's a kind of planning information. My work will give some idea. How can we include the green infrastructure for a sustainable development or a sustainability of a city? Nowadays, we know everybody. I know everyone present here, all of us are city people, city guys. And every day we are facing, from our experience, day by day, the living in city is getting hustle and bustle. A lot of things, a lot of new things are facing, those we are not facing previously. The temperature, especially the smoke, the rain intensity, the flash floods in the city, everything, water congestion, so many problems. Day by day, it is increasing. That means there is some planning, and there is some functionality problem in the city. And ultimately, what is affecting our life, everyday life? Because nowadays, in 2025, almost 54% worldwide living in the city, 54% people are living in the city, and it is forecasted that it will be 68%, 54% nowadays, and it will be 68% end of the 2030. It's amazing. That's with time, the climate impacts and the people actions and the functionality of the city, it will impact more people, more and more. So it's time now. We have to think the sustainability of our city. How can we take our actions? So let's, next. How we call it as a sustainable city? Because a city endures the social, environmental, economic stresses and performs as a resilient habitat for the current people and next generations. What happens when a city develops? It transforms the natural lands to artificial lands, and it creates heterogeneity heterogeneity in all directions, vertically and laterally. It transforms the natural lands to concretes. It changes the radiation pattern, the water balances. Ultimately, it affects the city habitats. There is a small diagram where how can we see it is presenting. When it meets, when the non-urban area, the radiation balance is more or less natural, and when it changes to urban land, it increases the outgoing radiation, keeping the radiation within the urban fabrics more, and enhance the sensible heats that we feel as a heat flux within the city. Let's have a look. It's a flow diagram. How can we see this? When urbanization, what does it mean? It concentrates more people. That means the metabolic activity is higher in the city, increased energy consumption, increased water consumption, and then it changes the urban landscape. It changes this hydrology of a city from natural states to artificial states. It changes the surface morphology. That means vertical heterogeneity has changed, and the lateral surface, and also the material type in the city. That means it's the more soil to more concrete type, more impervious. Then also what happened, the emission increases, heat increased in the city, gas particles increases in the city, water vapor also increases in the city. I don't know there is any point of, okay. What it says, overall it modifies the city's atmospheric conditions, atmospheric emission condition, transmissivity, roughness, interception of the infiltration of soil moisture and holding capacity of it. It changes the sky view factor of the city, and the albedo, that means the emissivity, and the thermal diffusibility of a city. At the end, all of these factors affecting and causing, ultimately it causes urban heat island. So, if we want to mitigate our urban heat island in a city where we are living, it depends on how it is functioning. Because some things we cannot change, like geographic location, time. There is a synoptic condition might be there. There's some heat flows by wind directions from the other wind directions. City size we can plan, and also the city forms. That means material geometry and the green space that we can think of it, and we can consider it to change and plan it to how can we use it for the mitigation urban heat island. And the city function, that the energy and water uses and its pollution. We can, different regulations and the policy making, we can also regulate these things, and we can plan to mitigate our urban heat island effects. So, for the city forms, the materials, geometry, and green space. Here we are considering the green space, that is vegetation. It can be the more sustainable, more cost-effective, and more efficient way to combat with the urban heat island effects in the city area. Why? These are some examples of the green space, green infrastructures. It's kind of living architecture. That we have seen. There's a lot of plantation in the city area. We are modifying. Say for example, in Dubai, they are using lots of vegetation with the urban fabric to mitigate the urban heat island. They use the shadows of the building to keep the next building cooler. There is a tree plantation, the green street trees, the bioretention of water-sensitive urban design, that could be the bioretention ponds, and the rainwater harvesting, and urban food production also could be the part of green infrastructure. Here is the next slide. It's a diagram where it shows how this infrastructure could input on modulating the different energy fluxes, and ultimately reduces the urban heat island effects. Why we are considering the vegetation as the most sustainable way to consider for the urban heat island effects? Because this vegetation has the capacity to bridge between water balance and the water energy balance. Because the evapotranspiration is such a factor, it uses water. It uses water to evaporize it as a latent heat flux. It uses, and when it flux the water as a water vapor, it reduces the heat emission in the city. So this, as much as we increase the evapotranspiration, it will use more and more latent heat flux. It reduces the sensible heat flux that we feel, and also the storage heat flux. These terms we will see here in the urban energy balance and water balance. You see, this is the evapotranspiration that in water balance part is ET, and there is also the latent heat flux in the urban energy balance. This is the common in those two energy balance factors, and these, because of these unique characteristics of this vegetation capacity, we can consider the most effective and sustainable way to mitigate the urban heat island. So next, urban fabric. To define or plan or where we want to put the infrastructure, green infrastructure effectively. So in an urban area, everywhere we don't need to put in green infrastructure. You need to plan it. To plan incorporating the green infrastructure in an urban area, we need to map detail urban land surfaces where it's heterogeneity laterally and vertically. So the satellite images has for example, weather station gives us the synoptic continuous data. It's okay, but it's point data. It's not spatially distributed. We need something that will provide us the spatial distributed information, like heat distribution information, and also the surface characteristics, like for example, the land cover, what sort of land cover is covering in an urban area, what is their variability of the height elevation, because elevation differences hinders the wind flow and retain heat within the urban fabric. So satellite images has this capability to model the land surface temperature and also the synaptic condition. It's retrieve this information, and the recent development of LiDAR data, it provides very high detail resolution of urban fabric information, the land cover and the elevation information. From satellite data, we cannot retrieve detailed land cover information that we need to model the urban heat island. Not urban heat island, to incorporate this infrastructure information effectively. We can, but it's not, this resolution factor is more. It's within urban fabric, as much as detail we can represent it as a planning information, planning will be the best. So for my study, for this study, we use this, data from different sources. The study area is in Melbourne metropolitan city. 3 city council area we have selected as a different type of land use, considering different type of land uses, and data collected from Australian spatial data sources. Melbourne impervious layer we have collected from Melbourne Water Authority, LiDAR data from 3 city councils area, Landsat satellite images, we use Landsat satellite images, and Moody's data we use for land surface temperature. And evapotranspiration, we have evapotranspiration and different energy fluxes we modeled used based on the energy balance approach developed by Allen and Bachiansal et al. Okay. And land surface parameter, surface roughness, we have derived from the LiDAR data. Let's have a look at the 3 land uses of 3 different studies areas. This is Melbourne City, and the 3 city council area we can visible here. The land use pattern in this 3 city council areas is totally different. Melbourne City Council area it's mostly business type. Monash is kind of residential. Monash and Darwin is also very newly developed city council area, mostly residentials. And the study that we have in this work, we follow a flow because every steps will input for the next steps. We derived the detailed land cover data from LiDAR, height morphometric parameter and height information from LiDAR, land surface temperature from satellite data, and heat fluxes using all these from LiDAR data and satellite data. And finally, we have statistically calculated the effects of surface characteristics on land surface temperature and different energy fluxes. This is the overall flow of the work, how we have calculated from how each of the parameters goes and flows and used for the next uses. For ancillary data, for example, we use land use data zonation, then the LiDAR data for surface characterization, weather station data, we use it for temperature modeling, and satellite data for temperature, and finally, statistical analysis for this thermal benefit. This is an schematic diagram for satellite and LiDAR data the acquisition. Satellite data resolution, thermal resolution is 120 meter and subsetted to 30 meter, and LiDAR data is centimeter resolution. So the detailness of LiDAR data, if we can use both together, the satellite data and the LiDAR data output will be the more precise. It more precisely represents the surface heterogeneous conditions. Let's have a look. This was the surface temperature that we have derived from the surface temperature for three LGS. I have presented here, for example, only for the summertime. You can see the variability of three city councils area. That one which is more business related, more urbanized, more impervious, it is showing more land surface temperature compared, which is more residential compared to that. It is less. Land surface temperature is less compared to which is more urbanized. And also this one, in the graph, it is the nighttime temperature from Moody's data. Also, we can see the nighttime, the area which the land uses, which is more impervious, more concrete surface is there. It retains more energy, more heat, and compared to the residential land use zones. This is the comparison between the measured land surface temperature and air temperature from weather station data. It's highly correlated. It's almost 0.9 correlation factor. It says that it means we can use the land surface spatial variability temperature with confidence for the spatial distribution in the whole city area. This one, it's the land cover mapping from LiDAR data. So you can see the detailedness of LiDAR data from green dots here in the LiDAR point cloud in the top left. That one is the green, is representing the vegetations. The red one, the point cloud only for buildings, and the polygons is here already extracted buildings and building polygons and tree polygons, and final product is in the at the left. It's all of the classes that has been derived from the LiDAR data as a point clouds, and the elevation also for all of them, for each of the building polygons and each of the tree polygons. You can see the detailedness of this, the LiDAR data, and how much it is efficient to represent as a nearly realistic representation of a city surface. This one is for statistical analysis. We need to compare this 120 meter land surface temperature, which is subsetted to 30 meter, and with the sub-meter, that means 0.3 centimeter resolution data, LiDAR data. So we have generated the spatial data, polygon vector file from LiDAR data. This one, the grid, that is overlaid grid on top of it. It's the 30-meter grid of Landsat data. And this one, the comparative for each of the 30-meter resolution has its, you can see in the B, in the middle, you can see how much variable. Each of the 30-meter grid is containing multiple land covers, like building, it's the building, impervious, grass, and trees. So this one is the detailed land cover map of three city councils areas. This one is, we can see where all of the three different, we can now count multiple land use classes and their fractional cover of fractional cover of grass, trees, and imperviousness covers of each different land uses at a 30-meter resolution fractional covers. So we have compared at the fractional cover level and the land surface temperatures for grass, trees, and the buildings and total imperviousness. You see, it is not similar in each of the, it is different for each of the city councils areas. For example, also we can see it is different in the different land use patterns and land use classes, which contains more vegetation. It shows less temperature, less surface temperatures. It is also the land use energy fluxes that has been modeled and compared with the land use classes, different land use classes. Then it is finally compared the vegetation and for vegetation. Here, two type vegetation we have land cover, we have mapped grass and trees, and the evapotranspiration of grass and trees has been compared, and we can see tree is more capable to, trees evaporation capability is much more higher than grass, and grass or shrubs, what we can say, and this is very much it is important to know for the urban planner when they are planning urban green infrastructure, that where they want to put the trees and where they want to put the grass for their urban heat island mitigations. So if we know when we have all this information, land use, land cover fractions, and this evapotranspiration information and energy and the evapotranspiration capacity on reducing the LST, that is land surface temperature for grass and trees, then planning information will be, planners will get help from this information where to put grass and where to put the trees. So from this, from that different graphs, I summarizes in the conclusion. Imperviousness increases the land surface temperature. It is obvious. In the summertime, it is higher compared to winter. It is obvious also. It is 6 to 1.3 degree in the summer and 3 to 0.03 to 0.7 in winter. And with increasing tree, it can reduce 1 to 0.7 degree in summer and 0.5 to 0.3 degree centigrade in winter. It is in Melbourne. It can be different for other cities. It is obviously for the other cities it will be different. And for the grass, if it is less, it is compared to tree, it is less. For 10% increment of grass, it can reduce only 0.2 to 0.5 in summer, and in winter 0.1 to 0.3. And also, impervious cover was dominating factors for spatial distribution of G and H, which means ground heat flux and sensible heat flux. So when we know the percentage of the imperviousness cover, the planners can plan. We have to put more trees or grass in that land use classes. So the planner can immediately plan that we have to put the grass here. So I'm almost finished there. So it's the last. And another thing is that compared to air surface temperature and land surface temperature, we can use the land surface temperature for model purpose and planning purpose effectively, because it's so very high correlations. This is and thank you very much. It's in time.
Thank you, Dr. Nuri. It was very insightful presentation and about an important topic for the planned urbanization. So we have a time for maybe one question. Yeah. Afterwards, we will proceed with the next presentation. So is there any questions from the audience? No? So I think your methodology and your outcome is really important about urbanization purposes. And in the opening session, the government representatives said that they are looking forward to receiving the outcomes of this conference, and your methodology and results can be adopted for the Kathmandu Valley, because it's also an extending urbanization. So that's why, thank you very much. So then,
thank you very much.
Fantastic. Our next speaker is Sweta Sejapati, and she's going to be talking about bridging the safety gap, earthquake desks to protect children in vulnerable schools in Nepal.
Thank you, convener. So, on behalf of my team, I'm Sweta Sejapati, and I would be presenting on bridging the safety gap, earthquake desks to protect children in vulnerable schools in Nepal. So I'm the national coordinator and currently working at Geohazard International. So first I would like to mention, in case of Nepal, everyone knows that school safety has been a major issue. And this has been a long understood and also a most researched part. In the 2015 earthquake as well, there was a lot of school that was damaged, but luckily we know that it was during a holiday, so there were no casualties. But even after that, like you can see in these photos, back So as you can see in these three photos, these are the photos from the 2023 Jajarkor earthquake. And you can see the schools has been extensively damaged. These are all the machinery structures. And so this also incident happened during the off days of the school. So there were no casualties. But just imagine if there were children in that school, what would have been the scenario? So, and the other thing is even the newly constructed buildings, right now, we cannot say that are 100%, we cannot say it is safer buildings because the building codes has just been implemented in Nepal and it has not been actually implemented in all over Nepal. So there we are just in an initial phase of implementing the building codes. So moving ahead, what Geohazard International has been doing in past years are we are trying to look at a different approach, a multifaceted approach to protect the school children. So one of the approach would be build a new school. So the photos here is the new school that we had built in Godavari municipality in Kailali district. And we handed it over last year to the school authorities. Then the second one is to address existing vulnerable schools. So there are two actually points where I would like to discuss. The first one is the first one is the engineer and mason training. So right now we are planning for a new mason training and engineer training for new construction as well as incorporate the retrofit techniques. And our wish list is to actually demonstrate a school retrofit in far west Nepal. And the third one is we're looking at an interim solution. As per a study of the government, we know that if we go for a new construction and also for retrofitting the vulnerable school, it will take more than 200 years to make all the schools safer. So that's a very long time, and we cannot even imagine, what would be the scenario if we wait for such long time. So we have brought out an interim solution. It is the earthquake desk that we have introduced newly in Nepal. And this is the earthquake desk, and the earthquake desk is a specially engineered classroom desk designed to protect school children by providing a safer space under the decks where they can take shelter during earthquake shaking. So it was originally developed in Israel and has been tested in Italy, and Geohazard International has also later manufactured these decks in Bhutan, and about 200 decks are being used there at present. And in Nepal, we have been doing a partnership with different organizations. So our local implementing partner is National Society for Earthquake Technology Nepal, NSET, and also the DEX designer, Ido Bruno and Arthur Bruter. And then we have ARUP, who are supporting us with the simulation part, and also with the Institute of Engineering, who has helped us to do all our physical tests. So I would like to give a brief about what is the earthquake desk. So for most of you, it must be a new thing. As I already mentioned, these earthquake desks are specially engineered desks. And if you can see, it is very different from a regular school desk that you've been seeing. And the main thing is, it has a wooden top, but all the other sections are made up of a steel. And this is a locally made desk, which is it has been made using all the local materials that are available in Nepal. And if you see where it is highlighted B, they have like 4 fuses in the decks. So the fuses are made in such a way that when a debris fall over the decks, it will actually insert or actually bend so that the energy can be dissipated. And also the legs, if you can see, this is actually a desk for 2 students to fit under to take the shelter. And the legs are made up of steel sections, whereas the middle 2 legs are actually not attached to the floor. It is just like few millimeters above the floor, so that when a debris falls over the decks, it will actually press the decks inside and protecting it from toppling over. So that is one of the purpose. And also it has used the rubber shoes, which stops the decks from slipping over. And also the diagonal beams, like mentioned in point D, it also releases the extra energy. And in context of Nepal, we made a few modifications which was not initially tested in any other countries. And so the first thing is, as I already mentioned, we've been using the locally available materials. So when we actually went ahead and did all these research on the available materials, we found that the materials available in Bhutan and Nepal were very different. Like in terms of the consistency in the size, in terms of the quality of the material, it was very different. So we were not sure how the decks would perform, which was locally manufactured. And the second point, what we did was we added the side protection. So actually, if you see on the photos on the right-hand side, you can see, there are this, wooden panels attached on the side of the decks. So the main purpose of those side panels are to protect the stones, masonry structures. When they fall, the stone can easily enter into the empty space. So that those side protection are actually built so that they can protect the stone from entering into the decks and like hurting the school kids. And also, initially, the decks was designed for only adult students. But in Nepal, there are cases where small primary school kids are placed in the most vulnerable buildings. So we thought we would need 2 different sizes of the decks. So we went to manufacture the primary school decks as well as the adult, and that is the higher secondary school decks. So the first part of this study was, of this project, included the feasibility study, where we visited like 62 schools in the far west. So at the moment, we are focusing in the far west because of the high risk of earthquake in that areas, and also because of the existing of large number of vulnerable schools, especially the stone masonry buildings. And the feasibility study also helped us to identify the sizes of the classroom, the layout of the classroom, how many students are studying in a particular classes, and so on. And from these, the main findings were like 89% of the school buildings are seismically vulnerable. So we can just imagine at what risk we are sending our kids to the school, right? And this was also validated from the NDRMA, that is National Disaster Risk Reduction and Management Authority's data. They recently conducted a rapid visual assessment all over Nepal, and this result was also the NDRMA's result also showed the similar result. So, so we are like, this interim solution is kind of a must in those areas. And the other thing we found out was the normal school decks are very narrow and typically would have 3 or 4 students seated in one desk. So even if there is a shaking and if they want to take shelter under the decks, that would be very difficult for them. And the other was the classroom was overly crowded. Like you can have like 60 or 70 students in a classroom. Even though that is not allowed by a government protocol, the schools has been doing so. So that was major finding. And also, as I mentioned, we needed a smaller decks for small school kids. And so the conclusion of these feasibility study was that the decks needs enough safety spaces for the children to take shelter. And the narrow decks, because it is very narrow, it can just topple over or easily break if there is a debris falling over. And we must prioritize these decks in the most vulnerable schools. And also, this gives us a hint about making a smaller size decks. And next, what we did was we evaluated manufacturers in Kathmandu, in Kailali, Bankhe, Darhildhura districts. And here are some of the photos where we were building this prototype decks. And the major finding of when we were looking at evaluating many manufacturers was that if we go for a locally manufactured decks, we need to have a local manufacturer. because that would significantly reduce the cost of the transport of the decks if that dex was made in Kathmandu and sent it over to the far west. So those costs would also, saving that cost would mean that we can make more decks and give it to the most vulnerable schools. And we are still, right now we have only like 3 manufacturers trained, but we are looking forward to train more manufacturers. And the next step, what we did was we made the prototype design and we tested it in Institute of Engineering, Puljok. And we did 2 types of tests. The first one was the vertical test, that was the compression strength test, where we exactly wanted to know when the decks would be deformed and what is the load capacity of the decks. So we did it for 3 different types, as can be shown in the photos. And the second test was the shock table test, and that was also done in coordination with Department of Civil Engineering, Puljok campus. And here are some of the results of the test. The 2-point concentric test, you can see the breaking pattern of the decks is in a W way. So that means the side fuses were bent and observe the energy, right? And if we talk about the 2-point eccentric test, where only one side was provided with the load, the fuses has actually inserted into the leg and has saved the space under the decks. And also for the uniform decks, also we can see in all these 3 results, we can see the space under has been protected. And the decks actually observed about 98 to 168 kilonewton before reaching a significant deformation. And we had to stop the test because of the limitation of the testing machine itself. And this was also the first time we tested it for the primary school decks, and the result was almost similar to what we would expect for the bigger decks. And this is the shock table test. We built one classroom on top of a shock table, and this model was actually inspired from the typical school buildings in Jajakot, which we found during our, which was damaged actually during the November 2023 earthquake. So I will show you a small video for this test. So the pendulum hits the shock table, and then there is a deformation of the building. So these are the results of the shock table test. So you can see the water jar, which is actually, we thought it'll be good to have some representation. We cannot put a kid inside the decks, right, during the test, so we thought it'll be good to have a water jar placed so that we can see if there are any damages to the water jar, so that we would understand if it would hurt school kids or not. So, and this was also done basically to test how the site protection would work. So you can see with the site protection, the debris has not entered the space below the decks as compared to the one without the site protection. And the interesting fact was all the decks actually retained the safety zone. So after this, we had various discussion meetings with the government, with the school authorities, and also the relevant stakeholders all over Nepal. So we did one in Kathmandu, we did in Far West, and what we did was during that workshop, we also did a live demonstration so that people would know how the decks would actually work when there is a load dropped over the decks, right? So what we did, this is actually, I'm going to show you a video, and this is from a workshop that we did in Dhangadi. And a load of 700 kilos were dropped from 3 meters, which is equivalent to a 1-story building. So, yeah, sure. So this was done in a school in Dhangadi. So the load is 700 kgs here. Yeah, so this was a way to kind of convince the government and all the school authorities that this decks can actually protect the school kids during the earthquake shaking. And as this project is still ongoing, we are moving into phase 3, and there are a lot of things that we are doing at the moment. And the first thing that we are doing is working with the government to incorporate this into the bring this text into implementing and placing this into the vulnerable school buildings. And for that, we are working on prioritizing which school we would work first. And we are using the NDRM's data, and also we're in regular coordination with the Central of Education and Human Resources, so that we can have more information about the school, their reconstruction plan, their merger plan, and so on. And also we're looking for more kind of a local manufacturer so that we can train more manufacturers and also reduce the cost factor. And also one of the essential thing about this DEX is we need to maintain that quality. We cannot compromise with the quality, So there need to be a certain guideline which would mark the quality of the DEX and also the quality of the product. So we're also working for the process of quality control and quality assessment. And this work, I would like to remember all the team members who have put the effort into the desk, and more than 20 people from 10 countries have been working in this project to make it a success. So I would like to remember my team members and everyone who have worked hard for this project. Thank you.
Any questions? Thank you very much. Well, we're going quick now. Any questions? A really interesting talk. Wait, come on, there must be one. Thank you.
Sorry, I can't finish.
Yeah. What about the cost analysis, whether the schools in the rural areas can afford those decks, because you need to buy many, right? Not one or two for testing. So if you want to equip with such schools with several decks, so is there any such analysis? Thank you.
Yeah, we did the cost analysis as well, and we found out that the regular school decks of 3 students' decks would cost about 7,000 Nepalese rupees, and the 4-seater decks would cost about 10,000. And there is a practice in Nepal that we have to, the decks are regularly changed, in a year period, on an annual basis. The decks are actually modified or they need maintenance. So when we incorporate all those factors, the cost of these earthquake decks is similar to the regular decks. And because this was a prototype design, the cost of the decks was about 15,000. So that's why we're looking for ways where we can actually reduce the cost itself. So one of the factors being locally manufactured so that we can reduce the transportation cost. Other would be if we go for a larger volume production, the cost of the decks would be less than the prototype decks. So those are the factors that we're still looking forward to. Yeah, please.
Very interesting presentation, thank you very much. And regarding the procedure that kids and younger boys and girls can follow for using these desks, because maybe this is another valuable point to take into account.
Yeah.
So did you conceive some procedure, standard procedure that both younger students and the others can follow?
Yeah, so we've been doing a lot of work, especially on the school sector itself. And the one thing that we have been doing is we're doing a regular earthquake drills in the school. So that was not a part of this project, but we've been doing it throughout the years. And the other plan for this is when we actually implement the decks in the schools, we're also going to do an earthquake drill and show how do kids to use these decks. Actually, how, if the way we communicate with the kids are wrong, then that could have a negative impact. Yeah, so our plan is when we place that decks, because we are not yet in that phase, but in next phase we are also planning for the earthquake drills and teach properly how to use this. Thank you.
Yeah, thank you very much. Thanks for the questions. It's a very interesting topic. So I would like to introduce the next presenter, Lisha Hay, to present the study on shear behavior characteristics of completely weathered granite soil based on ring shear tests. Thank you very much.
Good afternoon, everyone. My name is Heidi Sha, and I'm a PhD student in geotechnical engineering at Tongji University. My research focuses on the rainfall-induced landslides and their mechanical behavior. Today, I'm excited to share my work titled Study on Shear Behavior Characteristics of Completely Weathered Granite Soil Based on Rain Shear Test. Next, I will present my report from 4 aspects. First, it's a research background. Under the influence of global climate change, the frequency of extreme rainfall events has been continuously increasing, making rainfall events more extreme and difficult to predict. Meanwhile, extreme rainfall events can trigger natural hazards such as shallow landslides and debris flows. Statistics show that since the 1940s, the number of landslides has increased significantly. In particular, large-scale landslides induced by extreme rainfall occur frequently in Southeast Asia. This has become a major challenge for geological disaster prevention in many countries. Therefore, it is particularly important to conduct in-depth research on rainfall-induced landslides. To better understand the evolution and triggering mechanism of landslides, this study focuses on southeastern China in recent years. This region has experienced frequent shallow soil landslides due to typhoons and torrential rains. These landslides are characterized by their sudden onset, rapid deformation, and wild-affected areas, resulting in significant quality and property damage. For example, in Fujian province, southeast China, Wuping county of Longyan city experienced record-breaking torrential rainfall in June 2024. This event triggered approximately 16,000 large-scale shallow landslides and resulting in severe impacts on people's lives and property. The completely weathered granite are widely spread in the southeastern China, and this granite extensively covers slopes and serves as the primary geological carrier for landslides in this region. The soil layer has a loose structure, soften easily when exposed to water, and exhibit poor physical and mechanical properties. Under extreme rainfall conditions, they are highly susceptible to triggering cluster landslides, seriously threatening the safety of people and property. So, in the long term, studying the distribution patterns and triggering mechanism of landslides will help deepen our understanding of landslides mechanism and develop effective prevention and control measures. Next, the second part is material and methods. The study area is located in Huangzhutang Village, Xiaba Township, Wuping County, Fujian Province, China. We conducted a field survey in this area. We selected a typical landslide in this area, the Huangzhutang landslide, as the research object. Simple point was set up at its rear edge, and samples were collected from the specific soil layers to provide samples for subsequent laboratory test analysis. The test material was the completely weathered granite samples collected earlier, mainly composed of coarse-grained quartz, highly weathered feldspar, and kaolinite. The soil appears sprayed a brick red in color. A series of geotechnical tests were conducted to determine the physical and mechanical property of the test soil, as summarized in the table. Remolded soil samples were used in this study. During sample preparation, the field collected soil was first crushed and oven dried. dried soil was passed through to a 2 millimeters sieve to remove coarse particles to minimize the side effects. Finally, samples with different water contents were prepared and then used for testing. The test study, the experimental study were conducted using the rain shear apparatus from Tongji University. This study investigates the influence of different controlling factors of the shared characteristics of the soil. The test variables include 4 levels of normal stress, 4 degrees of saturation, and 10 shear rates. Before testing, the relative density of all specimens were carefully controlled at approximately 77%. The test conditions are summarized in Table 2. And the next part is the results. The test results indicate that most specimens exhibited evident strain shifting behavior. As the shear strain increased, the shear strength initially rose to a peak value and then gradually decreased until reaching a stable value. And a quantitative analysis further showed that the shear strength of the soil had a strong correlation with the applied normal stress. In addition, it can be observed that the difference between the peak shear strength and the residual shear strength varied significantly, and different normal stress, and this difference showed a linear relationship between the normal stress, suggesting that the overburden pressure on the soil is an important factor influencing its shear strength characteristics. Based on the vertical displacement curves during the shear process, it can be seen that specimens subjected to higher normal stress generally exhibited greater density and greater shear contraction. This demonstrates that the increasing normal stress enhances particle bonding, friction, and interlocking within the soil. Consequently, specimens under higher normal stress tend to exhibit greater residual shear strength. So to investigate the influence of saturation on the mechanical properties of landslide, shear test was conducted on soil under different saturation conditions. As shown in the figure, the stress shear displacement responses at varying water contents indicate that the stress curves of completely wet granite are significantly affected by changes in both normal stress and water content. And these two figures further illustrate the relationship between peak and residual shear strength and saturation. The results show that overall the shear strength of the specimen decreased as saturation increased. However, under low and high normal stress conditions, the variation patterns of shear strength exhibit some differences. The study further examined the relationship between shear strength parameters, mainly cohesion and internal friction angle and saturation. For cohesion, as saturation increases, both the peak and the radial cohesion gradually show a trend of first increasing and then significantly decreasing. For the internal friction angle, as saturation increases, both the peak and the residual friction angles exhibit a pattern of first decreasing, then increasing, and finally decreasing sharply. Overall, the internal friction angle shows a general downward trend. To better review the mechanism by which saturation affects the mechanical property of soil, both the microscopic and macroscopic characteristics of the soil or the shear zone were analyzed. For the macroscopic characteristics, observations were made of the shear zones in the specimens after shear testing. It was found that under dry conditions, the soil in the shear zone appeared relatively loose, exhibiting only slight cohesion and a certain internal friction angle. And at a saturation of 33%, the soil showed a distinctly loose and sand-like structure. At a saturation of 66%, the shear zone displayed noticeably bound, larger block-like structures. When the saturation reached approximately 100%, the soil gradually transitioned toward a fluidized state, and the shear zone after shearing became visibly slurry-like. At this stage, the shear strength of the soil decreased significantly. Regarding the microscopic characteristics, SEM's analyses were conducted on soil samples taken from the shear zone after testing. At a low saturation, the soil microstructure contains numerous pores. As the saturation increases, pore water acts as between particles, and its surface tension causes the particles to bond together, resulting in increased cohesion. When the water content continues to raise to a saturated state, the cementation effect of clay minerals weakens. Consequently, the shear strength decreases sharply. In addition, to investigate the rate effect, that is, the influence of shear rate, this study carried out continuous variable rate shearing, during which the shear rate was changed continuously 10 times without interruption, resulting in a final shear displacement of nearly 400 millimeters. The variation curves of the residual friction coefficient with shear displacement and different conditions are shown in the figure. From the test results, it can be seen that for most samples, the residual friction coefficient decrease as the shear rate increase, indicating an overall negative rate effect. The last part is conclusions. The main findings can be summarized in the following 3 points. Most specimens exhibited strain softening behavior during the shear process. The difference between the peak shear strength and the residual shear strength showed a linear correlation with normal stress, indicating a strong relationship between the shear strength of the soil and the applied normal stress. 2, the mechanical properties of completely wet granite are significantly influenced by changes in water content. Overall, the shear strength of the specimens decreases as saturation increases. In particular, when the water content corresponding to a given saturation exceeds the natural water content, both the peak and the residual strength parameters decrease with the increasing water content. When the soil approaches saturation, its shear strength drops sharply. This explains why rainfall is a key factor triggering shallow landslide sliding. 3, without any recovery time and continuously and increasing shear rates, the residual friction coefficient of the soil exhibits a negative rate effect. As the shear rate increases, the apparent viscosity during shearing trend to decrease, manifesting as the shear thinning behavior and resulting in lower shear strength. Okay, that's all. Thank you very much for the attention.
Thank you, Lei. Maybe you will have a few questions, we don't know, from the audience. Yeah, you can go back. So, is there any questions? Yeah?
Hello, Alicia. Okay, great, thank you. Very interesting results and very good research ideas. So my question is about how do you decide the arrangement of your normal stress and also saturation? Well, the design of saturation is easy to understand because you've distributed them all, right? But how do you decide the normal stress? Do you decide them according to the real case? Thank you.
mentioned shallow soil slides, right? Affecting the weathering zone of the granites. And they shouldn't be very deep. So why did you use, for example, 100 megapascal or
No moisture.
kilopascals?
Kilopascal, yes.
Kilopascals. So I think you use those normal stresses depending on the depth of the failure surface, maybe. Huh?
Maybe, yeah.
Maybe. Yeah.
Yeah.
I think it's something like that. Yeah. For the presentation to open. Sorry, I couldn't get your. Uh-huh.
Yes, yes. So actually the question is, what's the depth of your soil sample? How deep is it?
Where did you extract the soil samples? From which depth?
The soil samples was from the slope.
From the slope, from the surface or deeper parts?
Deeper.
Okay.
Yeah.
Because the granite layer was in the was below the 那个
It's fine, don't worry.
Fine.
It's fine, yeah.
the roots of the trees. So we must to dig the soil in deep depths, and we can get a completely weathered soil.
Yeah. Okay. How much deep? How many meters?
About approximately 1 to 3 meters.
Oh, okay. Okay, thank you very much.
Thank you very much.
Yeah. So. Okay, I would like to introduce the next presenter, Ashta Bata. Correct? Yeah, thank you. So her presentation title is Energy Dissipation and Rheological Characterization of Sand Clay Mixtures. Thank you.
Good afternoon, everyone. I'm Asta Bhatta, and I'm very pleased to be here in this WEG session. I'm currently hydropower engineer in Department of Electricity Development, and this research work was carried out during my study in the Hong Kong University of Science and Technology. So in this presentation, I'll first give a brief background and then move on to literature review and give test plan and procedures and move forward to research and discussions and finally end with summary. So let me give you a background about the big picture, why this research was carried out. The main objective for my research was to understand the debris flow and barrier interaction. So if we look at this schematics, so when the debris flow propagates, we generally use the Bernoulli's equation by assuming head loss and use to calculate different parameters of velocity and height. And when this debris flow interacts with the barrier, then there are different models to evaluate run-up and overflow. So for run-up, there are different methods, including momentum jump model and Bernoulli's equation. And to calculate the overflow, there are either two-phase models and dry granular method. But the major problem is that how do we evaluate the energy dissipation when there is flow and barrier interaction, especially when there is different flow material, because we know that debris flow is two-phase flow, and it's difficult to quantify the energy dissipation during flow barrier interaction. And for different types of flow, there have been many previous works that shows that the understanding the flow types is important. So I would like to focus on some previous research on influence of interstitial fluid regarding flow mobility and impact. The first one is from Du et al. 2022, where they did tests using different fluid type. And as you can see that as the clay content in the interstitial fluid increases, there is certain change in behavior which is represented by reduction in erodibility, which is shown by this graph. And in this one, this is for flow mobility. In this case as well, based on the different clay content, there is certain change in flow mobility. And also during the impact against the barrier, it was also found that as change in clay content, there is also change in behavior at the time of the impact as well. So the main understanding is that the flow behavior shows transition at different clay content. So we need to understand what happens when there is different clay content in the interstitial fluid. But this is the big pictures about what should be done. And in this study, I basically want to understand what happens when there are different kinds of fluid and how the shearing affects the different kinds of soil affects the shearing. And let me give a brief description about what happens when there are two different two-phase in debris flow. Like for fluid, we generally characterize it by viscosity or yield stress. And when talking about solid, we characterize by friction or cohesional stress. But when they get mixed together, there's different stresses playing role. And a few questions arises here that what governs the overall flow behavior and how can we quantify energy dissipation? Basically, rheometer is used to understand the characteristics of two-phase flow, but for debris flow, there is different amount of solid content from very dilute suspension to dense suspension. So the general concept of this concentric cylinder rheometer is that we cannot use it for dilute. Everything will be settled. Also for the ball probe rheometer, this will also settle. So there is a bit of difficulty when we need to characterize the dilute suspension. And regarding the parallel plate, due to its small size, so we can at least in some way, we can get the behavior of shearing, although there is a problem of spilling out. And I would like to move on to the oscillator ratio rheometer, which is used to calculate the shear stress and shear behavior by using the oscillation of solid two-phase flow by providing the oscillation. As you can see in these pictures, sinusoidal shearing is induced by rotating the top plate in parallel plate, and then resulting shear stress is measured. And based on that, we can get the viscous stress, which is in phase with the shear, which is out of phase with the shear strength, and elastic stress, which is in phase with the shear rate. By using this, we can quantify the viscous and elastic stress. There have been different studies for clay water mixtures and other liquid, which uses this method to quantify the viscoelastic response. But one major issue for our two-phase flow is that it is not always viscoelastic. We have plastic component that arises due to shearing. So in this research, I aim to quantify if we can use this method to calculate the plastic response using the oscillatory rheometer. So this is the response that we get for perfectly viscoelastic material. So for all the oscillation, we get one, this black graph is the shear stress and shear rate response. And for all the oscillation, we get one steady same graph. But when there is plastic portion, the assumption is that this will shift based on the different oscillation. As we as we rotate for number of oscillation, we will have an additional plastic response. So for this test, I use this same method and with different soil type. And as I mentioned earlier, in parallel plate, there is a problem of fluid being spilled out. So as you can see in the bottom right figure, I have used the additional adapter to stop the fluid two-phase mixture to spill out. The material used in this test was Toyora sand and kaolin clay and water mixtures. So now let me move on to the results. These are the results from the oscillation test at different shear amplitude. The vertical axis represents the storage modulus and loss modulus. As we can see in this graph, elastic and viscous effect shift dominance around 1 to 10% of strain amplitude across all mixtures, and plastic stress emerges at higher shear, altering the storage modulus behavior on the right-hand side of the shear strain amplitude. And furthermore, plateau at small amplitude of 20% clay indicates that it is almost in the linear viscoelastic region, and larger clay proportion leads to higher energy dissipation capacity. And previously I mentioned that I want to use this to quantify the plastic stress. So I would like to give an example of the points at 0.01% shear amplitude and 1000% shear amplitude. I use the two oscillation cycle to determine the plastic stress. So on the left-hand side, it is the graph determined for the two different cycles of oscillation at 0.01% shear strain amplitude for 20% sand with 20% clay water mixture, and right-hand side is for 1000% shear strain amplitude. In this graph, black lines represents the total stress curve, and red line represents viscoplastic stress, and green one represents the elastoplastic stress. We can see that between there are two different lines for same colors. That means that there is change between two cycles, and if we subtract the two cycles between elastoplastic stress, that means the green colors, we can get the plastic part of elastic stress. And if we subtract the two different red curves, then we can get the plastic part. So based on this, we can see that the stress-strain response of 0.01% strain amplitude lies in the elastic dominant region, which can be seen by the larger size of the shear stress of elastoplastic stress compared to the red one. And shear strain response at 1000 shear strain amplitude lies in the viscous dominant region, which can be inferred by the larger shear stress. That means the higher shear stress level of red curve compared to the green one. And difference between the consecutive cycles reveal that the plastic contribution, which is shown by the yellow part in both of the graphs. And using these areas under the stress strain curves, we can separate the elastic and viscous and plastic components for the two-phase flow mixtures. And that's now let me move on to the summary. Oscillatory shear stress reveal the rheological behavior and energy dissipation in sand, clay, water mixtures. Elastic and viscous effects shifts dominance around 1 to 10% shear amplitude, and marking the transition from elastic dominant to viscous dominant regime. Shear strain plot enables quantification of elastic, viscous, and plastic contribution. Thank you so much for listening.
Thank you, Ashta. Any questions? Because we have time to have a few discussions on the topic. I think there are no questions for you. Very well done presentation. Thank you very much. So the last presentation of this session, and afterwards we will proceed with the panel, is Chen Yu Liu. Yeah, thank you. And the presentation title is Exploring Joint Orientation Effects on the Failure of the Interbedded Rock Slope Using UDEC. Thank you.
Hello everyone, my name is Chen Yu Liu, and I come from National Zhongxin University in Taiwan. And today I will share a research authored Professor Yaju Qiu. Taiwan is mountainous island with complex geology, and the Western Foothill Belt is mainly consists of younger sedimentary rocks with slopes, interbedded sandstone and shale. Due to the different weathering resistance of these rocks, differential erosion occurs, leading to rock falls. And therefore, this study focuses on a typical differential eroded slope in Miaoli County, where geological surveys and numerical modeling were conducted to investigate the effects of differential erosion and changes in the orientations of specific joint on the frequency, slope, failure, and slope geometry. Based on field investigations and previous studies, the study areas consist of sandstone and shale interbedded with 5 sets of discontinuities, among which one joint set of J4 is roughly parallel to the slope. Based on the point cloud model of the study areas, a suitable cross-section was chosen to construct the basic UDEC model. The base block of the model is fixed, while other sandstone and shale are free, and each sandstone layer is 4 meters thick, and each shale layer is 1 meter thick. Due to simulation collapses caused by differential erosion, the material simulation was carried out in multiple steps, like these images. In each step, a 0.3 meters thick shale layer near the slope surface is first removed, and the simulation is solved to balance before proceeding to the next step. These studies analyzed of sandstone collapses and exhibited significant displacement to know the collapses frequency and numbers of collapses. And the simulation result of the basic models shows the model experiences 3 collapses with collapse areas exceeding 10 square meters. And failure was caused by shell erosions, will lead to formation of overhanging sandstone rocks, become unstable and failure. The slope geometry after each collapse shows that J4 forms the slope surface, and J3 only has a minor influence. The basic shows major differentiation along J3 and J4. Therefore, adjustments were made to their orientations. The orientation adjustments were obtained by inputting the Fisher consistent K values of J3 and J4 into the 3-deck, followed by randomly selecting 3 casts with significant orientation difference for simulation. This imagery shows the steps when failure occurs in models J3-1 to J3-3. In this study, the basic model is overlapped with the simulation result of J3-1 to J3-3 at the self-weight step at step 10, step 20, and step 30 to observed in slope geometry. The simulation result of various J3 models shows the models experience 3 or 4 collapses with collapses areas exceeding 10 square meters. And J3-1 is blue line, and J3-2 is a green line. They fail more frequently, but the impact of each failure was relatively minor, and they exhibit similar trends of failure timing and areas, and both tend to form overhanging rocks after failure. And this imagery shows the steps when failure occurs in model J4-1 to J4-3. The simulation result of various J4 models shows the models experience 3 to 6 collapses with collapses areas exceeding 10 square meters. And J4-1 is a blue line. It shows a pattern of 2 consecutively larger scale collapses. J4-3 is an orange line. It exhibits multiple sequences of collapse events, each consisting of 2 large-scale collapses. And the imagery below shows the post-failure slope geometry varies depending on J4. Finally, conclusions are as follows. First, changing the orientation of joints affects the frequencies of collapses, especially for joint sets that are neuroparallel to the slope surface. Second, the joint sets that are nearly parallel to the slope surface don't exhibit the same failure frequencies as different dip, but most dips still show their own failure patterns. Finally, in different models, joint sets that are nearly parallel to the slope surface from the failure boundary during collapse and the post-failure slope surface varies with the depth of this joint set. Oh, thank you for listening.
Thank you very much. Before taking the questions, I have an announcement. If there is anyone here having a poster, you are being called from the poster session hall here outside here this fall. Yeah, I think there's nobody. Yeah, okay then. We can go through the questions. Are there any questions for this presentation? Yeah, I think no. So we are ending our presentation part, and we will proceed right after that with our panel. Thank you very much.
So can we have our speakers back up to the stage, please?
And the other presenter to receive the award is Sweta Sijapati. Thank you. And Lisha Hay. I think, okay, she's coming. And Ashtapata. And Chen Yu Liu. Should I call myself?
Maybe I'd like to request Dr. Dahal to come on the stage and hand over the token of appreciation for our convener of the session and coordinators also.
Okay. So,
At the center, at the center.
so this is a very good opportunity for me. Yeah. Thank you. We make it very so happy. Okay, here you are, my dear. Thank you. 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 Thank you.
Thank you very much. So the technical session is over here. Now we will move on to the panel discussion session. So we'll take 5 minutes to arrange the seating. The tea is outside. If you'd like to have tea, go outside and bring the tea, and we can have the panel discussion, drinking tea or coffee also. Thank you. Shall we start? Oh, okay. Okay, so we are going to start our panel discussion. So first of all, I'd like to request convener Dr. Anne Williams to be seated on the dais for the panel discussion. So next, I'd like to request Dr. Ranjan Kumar Dahal also to be seated on the dais for the panel discussion. So next, I would like to request Dr. Mahmouda Khatun to be seated in the dais for the panel discussion. So next, I'd also like to request Dr. Hiromi Kaji to be seated on the dais for the panel discussion. So next, I'd like to request our moderators, Dr. Sweta Sijapati and Ms. Angela Babu Molla, for the moderation of this panel discussion.
Thank you, Dr. Manita. To begin with the panel discussion, I would like to give a short bio of each of our panelists present here today. To begin with, Dr. Anne Williams is a technical specialist in the field of engineering geology and hydrogeology based in Auckland, New Zealand. As a consultant, she has scoped, directed, and reviewed projects across New Zealand and in Australia, Pacific, and Southeast Asia for concept design through investigation, modeling, consenting to construction. As a manager of 360 people, a board member of Engineering New Zealand, a past chair and life member of the New Zealand Geotechnical Society, Inc., and past vice president of IAEG, and has significant first-hand experience of the opportunities for women in the discipline. Anne was the recipient of the 2022 NZGS Geomatics Lecture Award. Anne was the first female and our first engineering geologist to take on most of these roles or recognition awards. She's somewhat dismayed as the number of firsts still to be had for women in engineering geology in 2024. We would like to welcome you, Dr. Anne. Dr. Ranjan Kumar Dahal is a veteran geologist and geohazard expert with over 28 years of experience in engineering geology, landslide, and disaster risk management. He holds a PhD and postdoctoral credentials in geohazards from Japan and currently serves as an associate professor at Tribhuvan University's Central Department of Geology. Dr. Dhakal has made significant contribution to the field, with over 120 published research papers and several books on topics like landslide, earthquakes, and hydroclimatic disasters. As Vice President of the International Association for Engineering, Geology, and the Environment, IAEG, for Asia, and Deputy Director General of the International Consortium on Geodisaster Reduction, ICGDR, he works closely with global experts to reduce disaster risk. Known for his innovative approaches, Dr. Dhakal has developed rockfall hazard mitigation systems and led groundbreaking landslide risk management initiatives in Nepal and beyond. His work has been recognized internationally, including being named the Young Scientist of Nepal by the Nepal Academy of Science and Technology. We would like to welcome Dr. Dhakal for the panel discussion. Dr. Mahmouda Khatun holds a PhD in geological science from Jahangir University. Sorry. Her research focuses on engineering geology and geohazards in Rangamati. She also completed an MTech and postgraduate diploma in remote sensing and GIS. Currently a professor of Jahangir University, she has published widely and is active in professional organizations, including IAEG Bangladesh and the National Earthquake Society of Bangladesh. Dr. Khatun is IBNG WEG Chair and represents Bangladesh at ARC 15 of IAEG. We would like to welcome Dr. Khatun. Dr. Hiromi Kaji holds a master's degree in science in 2001, and after teaching experience began, she worked as a geological engineer at Oyo Corporation. In 2020, she received a PhD. She received a PhD for her research on the relationship between landslide and geological structure. She currently works in the offshore wind power division, focusing on seabed geological risk assessment. We would like to welcome Dr. Hiromi for the panel discussion. So interestingly, we have 3 female and 1 male in this panel. So we would 33%. Yeah, and so we were thinking of getting a perspective from both the female as well as male for this panel discussion, which is titled as Global Perspectives on Women Careers in Engineering Geology, Overcoming Barriers and Creating Opportunities. To begin with the panel discussion, we would be asking a few questions to the panelists here, and then we would also be taking questions from the audience as well. To begin with, I would like to ask same question to 3 of the female panelists present here, and I would request Dr. Ann Williams to respond to this question first. So the question to you is, what have been the biggest professional barrier you faced in your engineering geology career, and how did you overcome them?
The biggest barriers?
Yeah, your biggest professional barriers.
Okay. I thought about this, and you know, I probably have been somewhat oblivious to barriers, and that's probably partly my personality. I had a very supportive professor, and so I just imagined that I would leave university, get a job, and all would be well. However, I graduated quite some time ago, around when the world share market crash occurred, and just after, and there were no jobs to be had. So I had to ring up. I went to the phone book and I rang up every consultancy that was listed, and went along and introduced myself. And eventually, I did find myself a position, a contract position. And so I learned to make myself very useful. But so probably the biggest challenge was actually getting the opportunity to do work. And once I had done that, most of my employers have been my advocates. So.
Just to add a bit to that, was that barrier basically because of the gender discrimination, like you being a female? Do you think you had a less opportunities because of that?
Probably not. It was probably the economic times, to be honest. Although, in my very first interview, and I'll share this with you, I went and I met with this gentleman, and he told me, well, in engineering geology, you go into the field and on construction sites, and there will be men there who will whistle at you, which is a compliment. And I must admit, I sat there and thought, wow. And I thought also, I don't want to work for you. So, yeah, I guess be careful what you say.
Thank you, Dr. Ann. I would like to ask the same question to Dr. Mahmouda Khatun.
Thank you for your question. In different situation in Bangladesh, not like in other countries. you know, in Bangladesh, women are working, but this situation is changing. But if I think 10 to 20 years back, this is we have barrier in engineering geology in women. This limited access in we have to go field, but it is difficult field work. And another gender equity, yes, here, but this is not too much, but this is gap is equal, I think. And nowadays, women are getting opportunity, leaderships, mentorships, and others activity. But if you want to go field, this is difficult for me. There is safety, security, another's like if you stay in night hold, there is a difficult situation in here. But this situation is overcoming now. We went together in gender, female and male, and hope so nowadays women are getting chance. In front of my two colleagues, they are leading very good projects and they are doing it. But this is not scenario at all places. This is for government and others academic. But if you go on NGO or non-government, this is totally different situation. Okay, I think we're getting overcoming this one. It will take time. Thank you.
Yeah. Just to add a bit, from your personal experience, have you had certain, encounters with such difficulties, like you mentioned before,
In 2017, in 2007, first I joined the Geological Survey of Bangladesh. When I joined the Geological Survey, one of my teachers, senior professor, you are joining here. I think you will not do work in these places. You just posting on employee. I said, no. That time, we 6 female are joined together and we went field and also doing other sort. After 7 years, I joined at faculty at Jahangir University. In this, we are 4 female in teacher. We are randomly going in field work for students. But still now it's other difficulties for women. Okay, thank you.
Yeah, thank you so much.
As I'm studying right now in Japan, so Dr. Hiromi Kaji, I would like to know about the same question, the professional barrier you face till now as a practitioner, because I heard from some of Japanese professors that in the academic field, they didn't face such difficulties. So as a practitioner, what kind of difficulties you faced? I want to know.
Okay, thank you for your question. And I think when I entered the university, half of students are men and half of students are women. So it's very special. Even I learned geology. So that time, it's, how can I say, the ratio of the men and women is almost same in high school. So that time, I didn't think that it's barrier or any, how can I say, problem or issue or something like that. But so that about the professional barriers, after I entered the company, I was very surprised because most of colleagues are men. So that time, but the chance or opportunity is very equal for us. And yes, yeah, that is my experience.
I must say something that occurred to me quite recently. I was working in an acting general manager role for a 15-month period. I was talking with the
general managers from some other consultancies, and we were talking about getting together to form a contract or an alliance partnership and to bid for some major work that was going on. And we were having some regular conversations. I was the only female, the other three were men. And then the conversations stopped. There were no meetings. And so I tried to find out what had gone on. And it turns out that my male colleagues had gone off on a fishing weekend and had come to an agreement amongst themselves about how they were going to take this contract forward, and that did not include my firm. And that was one of the times when I thought, gosh, being a female in this role, should I really not be in this role because I am harming the opportunity of the business? So that's one situation that happened reasonably recently.
Thank you so much for sharing that. Now I'd like to ask a question to Dr. Ranjan Kumar Dahal. Do you feel men and women experience the field of engineering geology differently? If so, what differences have you observed in terms of opportunities, responsibilities, or expectations? Do I need to repeat again?
No, I just put the point. Okay. Thank you, Sweta. You are right. For me, working with the women has a very wonderful experience, especially because, when I graduated from Trivandrum University, I think in 30 years ago, 30 or 32 years ago. So in that time, we were very few. In my class, I remember my batch, we are the girl-free batch. We don't have women student with us in that time. So that was the situation that we grown up. So for us, the schooling is something like that. The daughters, or better say you're a girl or daughter or woman, whatever. The girls or daughter in your family means it is a burden to the father. This is the understanding that if you frankly ask us, being a Nepali society, what I can say that we were grown up with that ideology. Daughters are the burden to the father. So, luckily, I got two daughters. When I married, and my wife and myself, we have two daughters right now. When my daughter born in my family, then I realized now how to tackle the things, because we were very clearly taught by our family, or let's say my seniors, or my schooling, in the family schooling, better to say, was something like that. The daughters are the burden, okay? So that was a really very hard time for me. Even when my elder daughter was born, 2 or 3 days, I was not accepting the situation. That was the situation. That's really, sometimes I feel very hard when I remember those days. So this is how we are grown up in our society. So later on, being these international activities, participating in the international activities, as well as having some more professional activities, then I realized the things behind it. And my colleague Anne, I met her, I think, in 2006 or 2010, I think, isn't it, Anne? So in that time, she was handling the whole Congress of IAEG. So that was like, oh, what is this? A woman is doing everything, okay, in that time. So she helped me a lot in that time, I still remember. So I saw these are some of the issues that with the engineering geology, the woman who has a degree in engineering geology. And she's one of the most ideal person for me to describe the thing. As you asked me for the how hard it is for the opportunity and respect and
opportunities, responsibilities, and expectations.
Expectation. So for the opportunity, I should say it's a very rare. If you want to have some you want to hire some expert, or you want to have your staff for engineering geology or civil engineering, the first choice will be boy or man. That's very true everywhere. And I'm the only one person, sometime, the company where I used to support as a consultant, where the executive director is lady, woman, Manita. She's the executive director there. So what I found that though Manita is there, it is hard to take or hire the woman candidate for that. So you can imagine the opportunity. Definitely there is no. And in my class, I used to say to our student that you all the girls in this room, please think you have a 50% opportunity than the boy in this room. So that is the first beginning for them. And then while they apply for the job, definitely it's very hard. The another is the responsibility, isn't it? You are talking about. Responsibility in what terms? Like for the woman or from the male side?
I think I wanted to ask, and I mentioned responsibilities, is how trustworthy do you think women are in this field? Like how easily you can trust for some kind of work? Like let's say, if you
You're
need
right.
to go to
I got
field
it. Yeah,
visits.
yeah, definitely. If you ask me in that way, if my assistant or my supporter or my research colleague, if they woman or girl is with me, then I always feel very safe than male. Because, if I ask something to male, believe me, they will bring the data 70% only. If I ask this work same to women, believe me, they will bring the 99% of the correct data. So this is my experience. And I can give a number of examples. Number of examples. Yeah, this is the thing that I'm expecting. I'm facing in my regular job. And asking job to girls or the women who are working in the engineering geology is very, very good that they can get. They usually try to get the accurate data and more data compared to the male. That is my understanding. And then the expectations. The expectation, believe me, the woman, if you hire some woman, what I found that the expectation with women, very few, there are few cases are there, but in the most of the cases, I should say 80%. 80% of the women, they never expect anything. Never. They don't ask, what is my salary? That is the thing that I have seen. What is my salary? They never ask. They ask from what day I have to join and from what day I have to start my field work.
I still remember, sir. So, when I was graduated from a master's, and at night, 9 p.m., he called me. So, Angela, do you want to join my company? Like, please support us. And then next day, he called me to the office, and I went, and I said nothing. So, from when should I join? And he said, okay, right now.
Yeah, I said, and I remember Angela and other girls candidate, they asked me, when it opens? I said, the opening time is 10 o'clock, and I don't know the closing time. I don't know when our consulting company closes. Sometime it will be 12 o'clock in midnight.
Yes.
We don't know. But the closing time, we don't know, and the opening time, most of the cases, we have a very positive responses. But there are few very bitter experiences also. When we give the job to some of the ladies, women candidates, when they go to the field to their male colleague, the problem is that in the rural area in Nepal, you will have a problem with the toilets. You'll have a problem of the lodge, hotel, small hotel or lodge. And then sometimes you have to share the room. The twin beds are there, and then our male candidates feel very uneasy to ask her what to do. And she's also very much denying, no, I will not share the room with you. So what is the problem? The male candidate has to sleep outside in the very cold day. So the next day he called me and said, please, sir, ask her to back. I don't want her to support my job. I don't want her. So please ask her to back and send us the male candidate, male colleague there. So this was happened there. So this is some of the issues, in our village area, because we have to go to the very rural side as an engineering geologist. We have to go to the rural area where you have a very few facilities. Even there is no toilet. Sometimes walking, one full day of walking, you will not see any single houses in the Himalayan terrain. So in that time, definitely it is a problematic. But nowadays, the systems are changing, but still we have some bitter experience on that one. And, but not exactly as a harassment and those things, not at all. But the thing is that like the problem was created by the woman candidate, and the male candidate was suffered a lot from her behavior. So that was also happen. That was also happened in our experience. Yeah.
Yeah, thank you, Dr. Dahal. I can see Dr. Ann nodding her head and not, not agreeing to your saying. Do you want to add something to it?
Well, it's a little frustrating, isn't it, that it's suddenly the woman's problem, and maybe the woman could say that the guy should go home, but that's another matter. Look, even though I come from New Zealand and I often worked in probably what's called the developed world, I suppose I also have worked quite widely in the Pacific, in some in places like West Papua, Papua New Guinea, and Indonesia, various parts of Indonesia, Timor. And I recall one project in Timor where I lived on a beach. My hut was made from palm fronds. I had a solar shower that I hung off a tree in the back. I gathered the water at low tide through the beach because there was no fresh water. So I have lived in quite rural environment as well. And in this case, I was the only female on site. I was responsible for a large drilling crew from mainland Indonesia. But I didn't ever feel unsafe. They were really supportive. It was a really positive experience for me. It was quite entertaining. They had created a bathroom for me, which had a hole in the ground that you could have buried me 10 times. But hey. But I also can recall another situation where I went to West Papua. And it was a job where I was sort of crashing around in the bush trying to find evidence of seismic activity and fault uplift. And there was a bit of an uprising starting on the island, and it was around payment to the mining company I was working for. And the first response, unfortunately, from my client was to have me rescued. And so they sent in the Papua New Guinea army. They came in a big old Russian helicopter and with their rifles over their shoulders, and they took me away. And honestly, I was more petrified being rescued than if I had stayed on site. But so it was kind of unsatisfactory because I had to leave early. I was the only female. They took me away, and I had to go home. My field work was mostly finished, so that was part of the decision making. But, yeah.
Since the extensive field work has already, Dr. Dahal, do you want to add?
Actually, listening her, it's really, really like in that sense, what I can say that the schooling, the family schooling is very important when you have this kind of opportunity and the expectation, whatever. The thing is that if you have a good family schooling regarding to your future career, I think probably the best thing is that like family need to understand this thing and don't make any kind of biased behavior to the daughter and son. That is my understanding from Nepali society. And I think from Bangladesh also, we are in the same kind of the family structure. We have the same kind of the problem. So probably this is the one point that we have to consider, different to Anne. If our girls did this kind of work in the site, probably it will be the big issue for the father, and he used to go there and catch her back to the home. Okay, so that's a different thing. So it's a matter of the family structures, society, cultural things also there. But whatever the thing, the main point is that women should be a good representation in all kind of a job. So that is the main point we have to consider, and definitely, a person like me and person like Manita, we are very much conscious on this particular topic, and we give a lot of priority. Always there. Priority is always there. And if there is a female candidate, I always force, you can ask Manita, I always force her, put this girl. Always. I never asked the boy. But she used to say that, no, this or probably she will face the problem. Look, this is the system that we have. Because she knew the issues. She knew her problem. So she can compare things to
I
things.
remember one thing. So I still remember last 3 years before when we were going for the Tarkegang field. So Dr. Manita and another staff in our office, they were telling, like, you should not go to the field. It will be very difficult for you. But Professor Dahal told me, if Angela is not going, then we should cancel this trip.
Yeah.
Because she can only do this.
Many times, many times.
I
That
still
do,
remember
do.
that.
Yeah, that I do. That I do very bad. Even for my student, you know, sometimes like the girls students, yeah, yes.
Thank you for this nice discussion. You know, just don't blame me. I don't want to not provide the opportunity.
Blaming you. I'm not blaming you.
Just I was just telling that at the time Angela was facing some back pain problem. That's why I was telling her not to go, because you have at the time, because of the Melamchi flood, the road was all washed out. We have to walk a long distance, and it was a very cold day. Like it's snowing, it was snowing. So that's why I told her.
She was concerned for my health.
Nothing else. Okay.
But actually, whatever, Sweta, you know, like this all discussion and the putting on the top on top of the opinion from Anne, what I realized that like definitely there is a challenge, and IAEG Wake Committee need to give some good guidelines for us. That's a point I want to raise here. Because we are talking about all the issues we know. So how to resolve this issue? That is the point we have to discuss, I think. And we know the issues in Nepal. We know the issues in India. Okay. So some of the one gentleman, just we are talking about the Wake program. With the EasyCon team in India. Next week we have the EasyCon meeting there. And then he replied me in the phone call that, don't talk into it. He replied me in phone call, and he replied me that, okay, he replied me in Hindi. अरे वो महिला लोग क्या करेंगे? वो तो ऐसा ही बातें करेंगे. Oh, the women, they talk only, and that's it. We don't have to care much about the wake. So that is the answer given by one of the gentlemen to me. So now you can imagine. So what is the situation right now in India? And the person is a very high-level person. So from that point, you can understand. See, what is this exact situation of the engineering, women in engineering geology? So that's very clear to me. For me, it's very open. Very open. I understood very clearly. So this is a matter of because we have a male-dominant society, and the male-dominant society never accept this thing. Oh man, okay, they talk, let them talk for a small corner. So this is the way
I think, Ranjan, that things are changing though, aren't they?
You are right.
Because I think when I graduated and started working, you know, I'd go and do drilling on a barge or something, or work in where I had to go in a contractor's site office, construction office, and often, you know, there would be like calendars of, I don't know if this happens in Nepal, but naked women or whatever. So you'd look at this and feel somewhat uncomfortable, but you wouldn't say anything because you didn't want to draw attention to yourself. And you would probably be the first person to hop in the basket and go down a pile hole because you had to prove that you were stronger and better, you know, not a wimp. But times have changed, and I think, of course, we have to be somewhat mindful of culture because culture is important to people in society. But at the same time, it's now not okay, I think, to do some of these things, and it's time to call them out. And we'll talk a bit about that on the Saturday session. But I think I've got a very nice example. One of my colleagues was on a barge doing the offshore drilling. She was managing the drilling program, and she had to use the bathrooms on the barge, and they had this calendar with the firm's name on it as well, and it had this topless woman, and she thought, well, shall I just say nothing? And then she thought, well, if I say nothing, they know I've seen this, and so then I'm condoning it. So she decided to do something about it. She decided to write an email to the manager. She didn't confront them there and then. She wrote an email to the manager of this person, and he did not know that their firm's name was on a calendar like that. And so they actually stopped work. They took all the staff and they did diversity and inclusion training for a day. And then my colleague also had a phone call from the CEO of this firm apologizing on the behalf of his staff. So it still it brings a tear to my eye because it was such a fabulous outcome.
Yeah, I think just 1 minute. What I want to say that this understanding is very clearly a guideline for us. So what to do next from IAEG committee. So from this, I think from this ARC IAEG discussion, this panel discussion, probably we can have some kind of the resolution on that particular aspect. Like what are the guidelines or what are the parameters that can help to any company or any other organization that they can hire women for their job. So that is my question to all of you.
Thank you, Dr. Lahal. We'll surely discuss about that. But before moving ahead, because we are talking a lot about the country perspective, the cultural aspect, and also the challenges in the field, I would like to also hear from Dr. Mahmouda and Dr. Hiromi about such challenges in their countries, if they have faced any such experiences and shared.
Thank you, Sweta. In my case, I can share this one. I did PhD in geotechnical engineering, especially in landslide area. When I went to data collection, some people are saying this is going on cinema. How did women are doing here? Yeah, what we will do this, you will give money. The NGO person, no, this is my research work. In field, this is too much difficult to count. But in my department, academically, every year we have a female candidate for engineering geology. Especially they are doing very good and they are working in very nationally and internationally. This situation is changing and randomly we will say, no, work in lab, go to field, not working in secondary data, collect first primary data and do it. But in this situation, we feel barriers, but now this is time to time changing. And I expect this situation will be good in favor for female. But you know, in Bangladesh, Muslim country, it is difficult. And we are, academically, we are 50% male and female. And male person are agreed to field work, but female family, cultural, other side, they did not expect how it possible. She will go alone. You will go, and if you want to go, okay. But we are very helping. We create a team and doing very good situation. I hope this situation will change. And for women in engineering geology, we also need correct but suitable guidelines that can help women, not only this, like third world countries people. I think in future, we will raise our voice. We will bury our audience. Hope so, and thank you.
Thank you, Dr. Mahmouda. Now, please, Dr. Hiromi, if you could put some thoughts about it as well.
Yes, thank you. Yeah, I'm thinking, and in Japan, I said our opportunity, men and women, is, I think, same. But actually, the men can, yes, how can I say? Dominating and smoothly to live, how can I say, yes. So it's actual situation, I think, and sometimes this is my feeling, but for men, is comfortable than for women on the work, because there are many men, they can talk with very smoothly or frequently, but if the woman in that group, sometimes difficult to openly to talk with them. Yes, because before, maybe the 100 ago or something like that, Japan also has the men in the high and ladies or women are low. Such kind of thinking person also available. So now also such kind of idea is still remaining, I think, and sometimes I feared. But getting the opportunity or circumstances is changing for comfortable to work for ladies.
Thank you, Dr. Hiromi. I think one of the biggest challenges for women in any field, I will not just say engineering, geology, but any field, is how they balance their work and their family life. That always comes up as the biggest challenge. So I would like to hear a bit about this. What do you think, how do you balance your work life? And what would you like to suggest the upcoming generation of the young engineers? How shall they move forward? Like, some are maybe planning to get married, like starting family, and some are just starting their work life, So being a professional and also like balancing their family life. From your experience, what would you like to suggest? I'll begin with Dr. Ann.
I mean, it's always a difficult question, and I mean, the reality is life is compromise. You're going to have to compromise somewhere, and fortunately, I suppose, times are changing, so almost all of my employees, both male and female, have partners who are also working. So oftentimes, actually, the male engineers or geologists who are married to doctors end up taking the time off instead of the female because the doctors are paid more than engineers. So this is quite entertaining because it means that preference, perhaps, around employing a male over a female because the female might go on parental leave is now not so certain. Parental leave is for anybody. In fact, we call it parental leave rather than maternity leave for that reason, because it can be male or female. But yes, I think it's not perfect. I have a daughter, but I also have a very flexible and helpful husband he was a school principal for a while, and so he has always had school holidays, which meant it was much easier to deal with childcare and that type of thing. And I was actually having this conversation with some of my friends who are also in management roles, who are female. One of them has no children. One of them has a partner who works from home. So there is compromise on both sides.
Thank you, Dr. Ann. I would like to ask Dr. Hiromi the same question.
Yes, thank you so much. And for the work-life balance challenges for women in Japan, largely in Japan, the caring children is role of the women. Now it's a little bit changing, but mainly like that. So when I had my daughter, I was very deeply think if I can go the field trip for a long time. So before entering the elementary school, my senior colleagues advised, before entering elementary school, you can go the business trip for a long time. For example, 2 weeks or 4 weeks. No, before, but after 3 years or something like that. Why? She she maybe does not remember I'm available or not. And I lived with my parents, so my parents did care my daughter. So I went to business trip for 2 weeks or maximum 3 months. That was acceptable or the possible. But after she entered the elementary school, I have to check her study or to bring to her, for example, swimming school or piano class or something like that. And there are no alternative person in my family because she wanted to stay with me. So I stopped to go to business trip for a long time. But however, I have to go the office every day. But my company had a rule: if you have any reason, for example, to caring child or caring parents or something like that, you can select work at home or work at office. So now I have work in office and half days a week work in home. So now I can have good work-life balance.
Thank you, Dr. Himari. The same question goes to you, Dr. Mahmood.
Thank you, Sweta. This is too much difficult. Now I'm in here, but I am carrying my babies in our phone. Their exam going on. I am taking. Yes, you are reaching home. You are taking. My husband is now also working in bank. This is difficult for him because starting 10 to 6 and at night they may be 8 or 9, 10. In academician, in this my case is relaxed, but those women are working in government and on fixed time 8 to 10, and this is that particular. We are always compromising and also doing, but in my case and overall for email I can say, we carefully do our duties and as early as possible. No delay and in right time in right duties in doing in female officers, others, researchers. And in female compromising always. Thank you.
Thank you, Dr. Mahmouda. It's really interesting to see how different countries, how different cultural aspects of different understanding of women working in different fields, like, and all. So now we would like to open this session for the audience. If anyone have question for our panelists, I would like them to name the panelists and ask the question. So, this is your huge opportunity to know from their experience, to if you're like facing difficulties or trying to understand what you're trying to do next. I think it's the best opportunity, and please make most out of it.
Dr. Manita, you don't have anything to say?
Yeah, you can ask me.
Please.
Like my one suggestion, like most of these things are related with the opportunity, because we want more opportunity to women. So in that case, if we can do something from the organizational point of view, if we can put forward some kind of regulatory things to the organization that at least they have to hire this much amount of at least female candidates in their work. So that could be more helpful for the future of women in any field. What do you think? It's my perspective.
Is it directed to all the panelists? Okay. So,
Who wants to answer?
anyone who wants to answer to this? So you were suggesting that employers are required to consider female candidates as well as male, and that's how it is at my firm. Initially, I was like, this feels a little bit uncomfortable, but it's not you must give a female a job. It's you must ensure that when you have a job application that there are both female and male applicants. And then you can decide which is the best. Or if they are both equivalent and you can't put one ahead of the other, then you employ the female. So that's how we operate at the moment. And if you think about it, it's not inequitable, I guess, because the male party has everything going for them, has all of the pluses, I suppose, and so you are just creating a small box for the female to stand on so that she is the same elevation as the male. Yeah.
Thank you, Dr. Ann. Like we're like bringing out different job opportunities, right? And here we are with the practitioner as well as academics. So is there any such remarkable difference, or if any of you can think that can hinder, the opportunities that can be provided to women from the practitioners? Like Anne has already mentioned that her company has dedicated a number of females to be hired, right? Is there any such in your company, Dr. Hiromi, or your universities? Are there such opportunities?
Thank you. In our case, the employment, those are government are, they have to take an exam, and then in university case also here is also. But those who are getting good results, there are opportunities. But not in non-government jobs, they are taking experience. And I think they should think about increasing and their safety and others, and I think good environment for work and teamwork, that will be good for nation. Thank you.
Dr. Hiromi?
Yeah, in Japan, nowadays, for increasing women engineer or the studying science or engineering science, for that, only for the exam to the ladies or girls, that kind of test exam also available. And for the academic, only the limited for women's to be the professional or assistant professional, such kind of exam also available. Yes, so now the company also needs the women's power, and the government also supporting to increase the number of engineering women's.
Thank you so much. Any questions from the audience? If your question is directed to any one of the panelists, please name it.
Thank you very much. I have enjoyed this panel discussion very much. It was excellent and wonderful, I would say. So in this panel discussion, you have addressed so many challenges women are facing in engineering geology in different cases in ratio to men. So I would like to ask, or you may say, it's my interest to know from Angela Mala, so what was your motivation to become an engineering geologist, and how are you managing these challenges in this field? Thank you very much.
Thank you so much. So my motivation, if I will say, Dr. Anjan Kumar Dahal. So when I entered my graduate college, so I met Dr. Ranjan Kumar Dahal there, and then the way he motivated me, like how the engineering geologist works and how we female. The first line he said, like, you are a girl, so 50% opportunity you are not getting. So you have to come in front by yourself. You have to be, like, you have to show yourself a little bit more than a man. So his first line was that. So he was my motivation for those things, and he told me, like, I worked like this, I studied like this, And then, yeah, I think I followed him. I studied under his supervision. I worked with him. He sent me for the PhD. Right now, my supervisor is there, my Professor Tetsuya Sakai. He is also supporting me a lot. So I think it is not like only female. If we are getting the opportunity, we are getting the support, it is not difficult. And the support should be given by male and female both. That is the thing.
Yeah.
So thank you so much.
Thank you very much.
Yeah, that was excellent, Angela. I know it might motivate a lot of young professionals here as well. Any other questions? At the back.
Hi, good evening. Myself, Dr. Mustafa from UAE. To Dr. Mahmouda, because just for a change, I want to inform you. Main thing is, if you see in Saudi, almost like 2 decades before, no woman can come out. One of my wife was as a doctor. She cannot even travel without any accompaniment at that time. Now, the era has changed now. This is just for information. My wife can walk freely at any midnight. So this is what I'm telling you now. The main motivation among the engineering geologists, see, when there is a profession for medical, they are motivating. So many doctors came. So among the lady engineering geologists, you have to motivate more people to come so that more part can be occupied by yourself, then you can diversify yourself. That's where we are lacking up. I don't know, in geologists, when I studied, only 1 or 2 girls were studying. Now, almost like 15, 20 girls are studying in a department. So I think the young generation, they have to motivate. This is what I believe. Thank you.
Excellent. I like it. Perfect.
I think that's exactly right, but I do think that there needs to be more women role models, and that's part of the whole purpose of WEG, that, you know, we've noticed that we don't have very many women vice presidents, for instance. We don't have women as keynote speakers. We don't have women in those roles that are visible and meaningful, and until we do that, then the women that come behind are not seeing their career path. They can't see who they can be. So that's what we're trying to do.
Thank you. We can take one last question if any one of you have.
Thank you for this opportunity. And my question goes to Anne. So we have been hearing a lot about women's empowerment and inclusion. Could you share what your organization or you have been doing to involve women and how you plan to further encourage and support the women in this field? So same question to Ranjan sir too.
Look, I really think that it's the only way to support women is to be there, to be a role model, to encourage them, to give them opportunities, to help them to see what they can be by doing it yourself. So that's probably all I can think of.
Okay, thank you. And the person for my side is that you are my student. You have been in my classes many times. So you remember my words, probably. The thing is that, like, definitely we have to take care about how you have to put yourself. Don't hide behind the social restrictions. So that is the one point you have to consider. And for my point, definitely we give the priority, but it doesn't mean that you don't know anything and you are going to get the job. That is also not possible. Being a woman and you have to get the job, stop it. That is not possible. You have to have some capacity to have some particular job. So in my opinion, make yourself first suitable for that job, or I should say the very blunt way, prove your degree, you will get the job. Getting degree is not the things. Prove your degree, you will get the job.
Sorry, just one more thing, that it reminds me of, when you do have the opportunity, when you go into the boardroom or whatever it is, don't sit at the back. sit at the table, be there, don't be too humble, because I think as women we tend to sit back and let the guys be there and talk, but be present and make sure that they remember that you were there.
Yeah. Thank you, Anne. And with this, we come to an end of this panel discussion. And today's session has been very important and have highlighted how the society is changing for the women and how women are being motivated to come up front and speak out for themselves. And also in this difficult field like geological engineering also, it has been a very motivational talk. And I hope this has inspired the next generation of the professional to come forward, to believe in themselves, and also to join on these kinds of programs where, you know, we can hear a lot of experience and get a lot of knowledge. So thank you, panelists, for this wonderful session.
I have a small request. Hello? I have a small request. Like today we finished our wake session. There is in the program file, we have one QR code. So that is a feedback survey of today's wake session. So please everyone, scan that code and fill up the feedback survey for our woman-led wake session of today's. Thank you so much.
So we are at the end of this panel discussion and end of today's sessions also. So before ending, I'd like to thank you all the panelists and the moderators for this wonderful discussion, and would like to present you some token of appreciation. So I'd like to request Dr. Kumudraj Kafle sir to present the token of appreciation to our panelists and our moderators also. I have to make one more announcement. Dr. Mahmouda Khatun has also brought some token of appreciation from Bangladesh to our panelists. So we'd like to request for that also, Dr. Mahmouda. Dr. Mahmouda, he also want to distribute the token of appreciation. Thank you so much, Dr. Mahmouda. So with this, we are at the end of the session, and I'd like to close this session. So now the dinner is from 6:30. So after here, you can enjoy the poster session also, and then we'll go to the dinner at 6:30. Maybe we'll have some cultural program also, and then we'll enjoy the dinner together.
Thank you. And in 6:30 we start our drink, so be ready to have a good drink here. We are providing some good Nepali beer and as well as some good Nepali wine as well. So please enjoy the drink at 6:30 onward. And meantime, please don't forget to come this hall. We have a number of Nepali and Bangladeshi dance shows here, the cultural shows. So please don't miss that one also. Thank you very much. 6:30 onward. 6:30 onward, we start our drink and dinner. And the dance program will be after 7. Dance, 7. Yes, cultural program with drink will start at 7.